roads, bridges, flyovers, and all other infrastructure. We are also involved in the execution of border fencing, flood lighting, and road projects in difficult terrain and hostile conditions along the borders. Our engineers are working at high altitude on Indo-China border, in the floodplains of Indo-Bangladesh border, and in deserts in Rajasthan and Rann of Kutch in Gujarat. CPWD is committed to keep pace with the technological advancement and adoption of indigenous, sustainable, and clean technology in our construction activities. We have adopted a large number of civil and E&M technologies, which are both environment friendly and locally available. In this context, I would like to mention that the prestigious Central Vista project and construction of new parliament building is being done utilizing all indigenous material from various parts of the country and incorporating latest technology and engineering skills of our own country, thus working towards Atmanirbhar Bharat. As for new technology introduction, we have introduced bamboo wood, densified calcium silicate false ceiling tiles for light gauge steel framework, aluminum formwork for monolithic construction of RCC, recycled aggregates for CC. On the E&M side, we have 5-star rated fans, VRV, VRF, air conditioning, solar photovoltaic generation plants, etc. And these are being encouraged in all our construction works. Under Sugamya Bharat, Accessible India Abhiyan, all existing buildings are being audited and the required facilities for accessibility are being provided. CPWD has also been playing a lead role in the country in dissemination of knowledge relating to practices in building industry, and this conference is part of that. This is in line with the vision of our Honorable PM for Atmanirbhar Bharat and Make in India mission. We have come up with our own rating mechanism also for Green Rating Standard, GHAR, GHAR, for the projects. CPWD will continue to lead in the adoption of more innovative indigenous technologies and materials, along with the use of renewable energy and greener construction practices across the country in future also. I would like to congratulate the Training Institute team, National CPWD Academy team now, along with Shri M.K. Mahobia, ADG TNR, for organizing this national level conference on indigenous engineering solutions, which is another step towards Atmanirbhar Bharat, as I mentioned earlier also. I'm sure that with the panorama of eminent speakers and their technical presentations today, the conference will be an enriching experience for all of us. Before I conclude, let me once again thank all the officers for participation and celebrating this Amrit Mahotsav in large numbers today. Thank you.
Thank you, sir, for your encouraging words. And we are enlightened by your words. And now I want to share that Secretary MOHUA was to preside over this conference, but due to some preoccupation, he is not with us today.
He's out of
but
station.
He had sent his message for us, which I would like to share with you, all of you. And I request my colleague Sri Satyendra Kumar to run this video message of Secretary sir.
ये शेयर कर रहे हैं आ रहा है
Yes sir. Yes sir.
महानिदेशक केंद्रीय लोक निर्माण विभाग एवं केंद्रीय लोक निर्माण विभाग के वरिष्ठ अधिकारीगण, सबसे पहले तो मैं विभाग को इस बात के लिए बहुत बहुत बधाई देना चाहता हूं कि आज इतने महत्वपूर्ण विषय इंडिजिनस इंजीनियरिंग सॉल्यूशंस इन कंस्ट्रक्शन ऑफ ए सेल्फ रिलायंट इंडिया के विषय पर चर्चा की जा रही है। मैं स्वयं आप सबके बीच उपस्थित होकर के आपसे सीधे संवाद करना चाह रहा था, किंतु कुछ अन्य जिम्मेदारियों की वजह से आज मुझे दिल्ली के बाहर रहना है। इसलिए मैं पहले से रिकॉर्डेड मैसेज के माध्यम से आप तक पहुंच रहा हूं। विषय है इंडिजिनस टेक्नोलॉजी फॉर सेल्फ रिलायंस इंडिया, यानी हमें कंस्ट्रक्शन की उन नई तकनीकियों को अंगीकार करना है जिससे जो कंस्ट्रक्शन का कार्य केंद्रीय लोक निर्माण विभाग कर रहा है उसको बहुत तेजी से कर सके। आज जो जलवायु परिवर्तन का एक मेजर चुनौती हमारे सामने है उसको भी हम एड्रेस कर सके। जो डिजास्टर को लेकर के एक चिंता होती है, चाहे वो साइक्लोन से हो, अर्थक्वेक से हो, अन्य प्रकार के किसी भी प्रकार के फ्लडिंग से हो, उससे भी हम लोग अपने आप को सुरक्षित रख सके, या कैसे हम अपने रिसोर्सेज को बेहतर से बेहतर उपयोग कर सकते हैं, चाहे वो हमारा वेस्ट रिसोर्सेज हो उसको कैसे उपयोग कर सकते हैं, या रिसोर्सेज को जो वेस्ट है उस वेस्ट को कैसे हम लोग कम कर सकते हैं। इसके बारे में माननीय प्रधानमंत्री जी के निर्देश पे एक हमारे मंत्रालय के द्वारा ग्लोबल हाउसिंग टेक्नोलॉजी चैलेंज इंडिया GSTC आई 2019 मार्च में किया गया था, जिसमें दुनिया की 54 अलग अलग किस्म की टेक्नोलॉजी, कंस्ट्रक्शन टेक्नोलॉजी के लोगों ने भाग लिया और उनमें से 6 टेक्नोलॉजी को हमने चैलेंज के माध्यम से अंगीकार किया है अपने देश में 6 स्थानों पे। सदर्न इंडिया में चेन्नई, वेस्टर्न इंडिया में राजकोट, सेंट्रल इंडिया में इंदौर, नॉर्दर्न इंडिया में लखनऊ, ईस्टर्न इंडिया में रांची और नॉर्थ ईस्टर्न में अगरतला। इन टेक्नोलॉजी की खासियत यह है कि बहुत कम समय में ये पूरा कंस्ट्रक्शन हो जाता है राजकोट में। और वहां मैंने जो टनल फॉर्म मोनोलिथिक कंस्ट्रक्शन का रूप देखा, मात्र 35 दिनों में 14 मंजिल की बिल्डिंग, एक नहीं 2-2 बिल्डिंग एक साथ बनके तैयार हो जाती है। क्या पैसा पहले सोच सकते थे? लेकिन अब उसका जो टनल फॉर्म है वो पूना में तैयार हो रहा है और मौके पे आकर के असेंबल हो जा रहा है। और ये कंस्ट्रक्शन आपको एक लंबा सुनिश्चितता भी देता है, 100 साल की इसकी जिंदगी होगी, साथ ही साथ आपको मेंटेनेंस से फ्री रखेगा, अलग से कुछ करने की आवश्यकता नहीं है। और जब एक बार हम इस टेक्नोलॉजी को अंगीकार कर लेंगे तो कॉस्ट बहुत तेजी से नीचे गिरेगा। जो चेन्नई में हमारा टेक्नोलॉजी चल रही है, वहां पे उसके बगल में ही एक फैक्ट्री जैसा माहौल है, मुश्किल से आधा किलोमीटर की दूरी पे मैंने खुद जाकर के देखा हुआ है। चाहे वो स्टेयर्स हो, बीम हो, दीवार हो, कॉलम्स हो, सारे के सारे जितने एलिमेंट है बिल्डिंग के, वो सारे के सारे वहां पे एक फैक्ट्री के रूप में तैयार हो रहे हैं, उनको लाकर के स्थान पे सम्मिलित कर लेते हैं। जो रांची में काम चल रहा है, एक बच्चे जो लेगो खेलते हैं, एक के ऊपर एक पूरा घर बना करके रखते चले जाते हैं। तो कैसे ये सब कुछ, बाकी सारे 6 जगह पे 6 अलग अलग टेक्नोलॉजी कैसे संभव है, ये सीखने की बात है। और इसके लिए हमने एक टेक्नोग्राही शुरुआत किया। ऐसे लोग जो सीखना चाहते हैं, चाहे कॉलेज के बच्चे हो, इंजीनियरिंग के बच्चे हो, आर्किटेक्चर के बच्चे हो, प्लानिंग के बच्चे हो, या ऐसे लोग जो प्रैक्टिशनर्स हो, आप जैसे लोग जो CPWD के अधिकारी अलग अलग इंजीनियरिंग शाखाओं के हो, या आर्किटेक्चर के हो, या स्टेट गवर्नमेंट के, प्राइवेट सेक्टर के, कोई भी टेक्नोग्राही के रूप में अपने आप को रजिस्टर कर सकता है। और रजिस्टर करने के बाद उसको पूरी जानकारी भी मिलेगी। अगर आप मौके पे जाकर देखना चाहें, कल ही जैसे मैं वहां पे जब गया था तो RK यूनिवर्सिटी के बच्चे वहां आए हुए थे, उनको मैंने एड्रेस भी किया, उनको सीखने का मौका मिलता है। और यही नहीं, एक नवरीत नाम से प्रोग्राम स्टार्ट किया गया है स्कूल ऑफ प्लानिंग आर्किटेक्चर दिल्ली और BMTPC बिल्डिंग मटेरियल टेक्नोलॉजी प्रमोशन काउंसिल, दोनों के सहयोग से एक कोर्स तैयार किया गया, ई-मॉड्यूल है नवरीत। उस प्रोग्राम को करने के बाद आपको न केवल ये 6 टेक्नोलॉजी बल्कि सारे 54 टेक्नोलॉजी के बारे में जानकारी मिलती है। और समय अब है कि हमें अब नई टेक्नोलॉजी को अंगीकार करना है। हाल में ही लखनऊ में जब हमने आजादी का अमृत महोत्सव मनाया था, तो हमारे माननीय प्रधानमंत्री जी ने एक देश में तैयार की हुई 75 नई टेक्नोलॉजीज का मैं उद्घाटन किया था। इसमें ऐसे तमाम किस्म की बातें थी, चाहे वो मड को लेकर के कैसे आप पूरा स्ट्रक्चर बना सकते हैं, कैसे आप कार्बन फुटप्रिंट को कम कर सकते हैं, कैसे आप जो है पराली है उसको लेके कर सकते हैं। ऐसे बहुत किस्म की टेक्नोलॉजी थी। मैं तो आपसे कहूंगा ये सारा डॉक्यूमेंटेशन हम इसको तैयार करा रहे हैं मिनिस्ट्री से। हमारे केंद्रीय लोक निर्माण विभाग के सारे इंजीनियर्स को उसको देखना चाहिए और जहां जरूरत हो, जहां संभव हो, वहां पे इन टेक्नोलॉजी का अंगीकार करें। और यही नहीं, आप लोग प्रैक्टिशनर्स हैं और एक प्रैक्टिशनर के तौर पे आप उनका फ्यूजन भी तैयार कर सकते हैं। 2-3 टेक्नोलॉजी को मिला के कुछ ऐसी चीज कर सकते हैं जो कि कहीं के लिए उपयोग हो। तो आप सब इंजीनियर्स हैं, आपने डिग्री हासिल किया, ऐसे अच्छे कॉलेज से डिग्री हासिल किया, क्यों नहीं ऐसा कुछ नया चीज करें जो कि हमारे देश के लिए, क्योंकि देश में चुनौती है, नए कंस्ट्रक्शन होने हैं, काफी मात्रा में कंस्ट्रक्शन होने, वो कंस्ट्रक्शन ऐसे हो जिससे हमारे क्लाइमेट को बुरा असर न पड़े, जिससे हमें रिसोर्सेज, चाहे वाटर हो, चाहे मड हो, चाहे अन्य रिसोर्सेज हो, उसका कम से कम प्रयोग हो, रिसोर्सेज का कम से कम वेस्टेज हो, वेस्टेज को हमको कम करना है, हमें तेजी से काम करने से हमारे कॉस्ट में भी अंकुश पड़ेगा। तो ये हमें अडॉप्ट करने की जरूरत है। ये भी हमें देखने की जरूरत है कि भविष्य में मेंटेनेंस के ऊपर कॉस्ट कम हो, लॉन्गेविटी बहुत ज्यादा हो। ये सारी बातों को देख करके हमें टेक्नोलॉजी को अंगीकार करना है। अभी हमारे देश में जब हमने ग्लोबल हाउसिंग टेक्नोलॉजी चैलेंज किया था, तो अफोर्डेबल सस्टेनेबल हाउसिंग एक्सेलरेटर इंडिया, इसके नाम से 5 केंद्रों का शुरुआत किया। IIT चेन्नई, जिसे IIT मद्रास कहते हैं, IIT मुंबई, IIT रुड़की, IIT खड़गपुर और सेंट्रल बिल्डिंग रिसर्च इंस्टीट्यूट जोरहाट में। इन 5 जगहों पे कोई भी क्रिएटिव आदमी, आप रिटायर्ड हैं तब भी, आप पढ़ रहे हैं तब भी, सर्विस में है, आप कोई नए किस्म की टेक्नोलॉजी इंक्यूबेट करना चाहते हैं, चाहे वो बिल्डिंग मटेरियल के बारे में हो, बिल्डिंग प्रोसेस के बारे में हो, बिल्डिंग टेक्नोलॉजी के बारे में हो, वहां पे आप इसे इंक्यूबेट कर सकते हैं। आपको पूरी सुविधा होगी, इसकी फंडिंग हमारे मंत्रालय के द्वारा की जा रही है। और उसके बाद उसको एक्सीलरेट करने के लिए वर्ल्ड रिसोर्स इंस्टीट्यूट WRI के माध्यम से कैसे उससे आप मार्केट रेडी कर सकते हैं, वो उसमें आपकी मदद करेंगे। जब हम टेक्नोलॉजी की बात करते हैं, अभी हाल में CPWD ने बहुत अच्छा काम किया अफ्रीका एवेन्यू के ऊपर, KG मार्ग के ऊपर, जो 2 हमारे डिफेंस ऑफिस कॉम्प्लेक्स बने हैं। मैं तो कहूंगा कि हर CPWD के अधिकारियों को वहां के जाकर देखना चाहिए कैसे इतनी बड़ी बिल्डिंग, 8 मंजिल और 7 मंजिल की बिल्डिंग, मात्र 12 महीने में, इसके बावजूद की कोविड-19 के चैलेंजेस थे, बन के तैयार हुई। और वहां पे स्टेट ऑफ आर्ट टेक्नोलॉजी है, चाहे वो सिक्योरिटी के बारे में हो, वहां के पूरा इंटीग्रेट IT सिस्टम के बारे में हो, या हमारे कंस्ट्रक्शन टेक्नोलॉजी के बारे में हो। हमें जब हम टेक्नोलॉजी की बात करते हैं तो हमें किस प्रकार से बिल्डिंग की प्लानिंग कैसे करें। आज बहुत सारे प्रोजेक्ट मैनेजमेंट के लिए तमाम किस्म के सॉफ्टवेयर बनकर के तैयार हैं। हमारे इंजीनियर्स को उसमें एक्सपर्टीज हासिल करनी चाहिए, जिससे कि हम अपना जो भी रिसोर्सेज है, चाहे वो मैन पावर हो, चाहे बिल्डिंग के रिसोर्सेज हो, चाहे फाइनेंसेज हो, उसको सही से हम लोग उसका उपयोग कर सकें। तो प्रोजेक्ट मैनेजमेंट भी अपने आप में एक चैलेंज है। आपको जानकारी होगी कि CPWD के लिए बड़े गौरव की बात है कि वो उन्हें एक ऐतिहासिक प्रोजेक्ट, सेंट्रल विस्टा प्रोजेक्ट के ऊपर काम करने का मौका मिला है। जैसे जो नई पार्लियामेंट बिल्डिंग बन रही है, इतनी कॉम्प्लेक्स बिल्डिंग मात्र 21 महीने में बनकर तैयार होगी। सेंट्रल वेस्टा एवेन्यू का जो काम हो रहा है, मात्र चंद महीनों में, 1 साल भी नहीं, उससे कम में, और जिस दिन बनकर के तैयार होगा वो एक नायाब चीज होगा। ये कैसे संभव हुआ है? न केवल इसमें टेक्नोलॉजी कंस्ट्रक्शन की है, बल्कि पूरी इसको प्रोसेस मैनेजमेंट करने के लिए हम लोग IT सिस्टम का प्रयोग करें। एक चीज पे हमारी पैनी नजर है, कहीं कोई चीज पीछे छूट भी ना पाए, और अगर छूट पाती है तो उसको हम लोग कैसे वापस लाइन पे ले आते हैं, ये एक बहुत आवश्यक चीज है। इसमें भी मैं समझता हूँ कि हमारे इंजीनियर्स को इसमें ध्यान देने की जरूरत है। प्रोजेक्ट मैनेजमेंट, बहुत इंपॉर्टेंट चीज है। एक लोक निर्माण विभाग का दायित्व न केवल अपने प्रोजेक्ट्स को लागू करने का होता है, बल्कि ये भारत सरकार के लिए एक कंसल्टेंट का भी काम करता है, परामर्शदाता का काम करता है। जो हमें नए स्टैंडर्ड्स तैयार करते हैं, वही स्टैंडर्ड्स बाकी सारी की सारी जितने भी इंजीनियरिंग ऑर्गेनाइजेशंस को लेते हैं। एसओआर आपके द्वारा तैयार किया जाता है, और एसओआर जो नई टेक्नोलॉजी के बारे में, मुझे खुशी है कि CPWD ने पीछे बहुत सारी नई टेक्नोलॉजी के बारे में एसओआर तैयार किया और आगे भी इस काम को कर रहे हैं, जिससे कि हमें आगे आने वाले समय में बिल्डिंग कंस्ट्रक्शन बेहतर से बेहतर हो, हम सस्टेनेबल कंस्ट्रक्शन कर सकें, हम ऐसे कंस्ट्रक्शन करें जो कि लो कार्बन फुटप्रिंट जिससे तैयार हो, ऐसा कुछ करें जिससे लोगों को जो भी वहां पे चाहे ऑफिस के रूप में यूज हो, चाहे वो घर के रूप में यूज हो, चाहे अन्य किसी प्रयोजन में यूज हो, हर प्रयोजन में उसको बेहतर से बेहतर माहौल हमारे कंस्ट्रक्शन के माध्यम से मिल सके। तो मैं आज जो ये आप पूरे दिन भर की चर्चा कर रहे हैं, इस पूरी चर्चा के लिए अपने तरफ से शुभकामनाएं देता हूं कि आपकी चर्चा बहुत सार्थक होगी और इस चर्चा के बाद ऐसे तमाम सारी बातें आएगी जिससे हमारे CPWD के अधिकारी रिजॉल्व लेंगे, आगे किस प्रकार से हमारा रास्ता हो, जिससे कि हम देश का जो आज जो आत्मनिर्भर भारत, जो एक नए भारत का निर्माण हो रहा है, उस नए भारत के निर्माण में इतनी महत्वपूर्ण एजेंसी भारत सरकार की केंद्रीय लोक निर्माण विभाग किस प्रकार से अपनी सार्थक भूमिका अदा कर सकती है। मैं आप सबको बहुत बहुत शुभकामनाएं देता हूँ। धन्यवाद। जय हिंद।
लग जाएगा तो स्पीड कम हो जाएगी, तो फिर वो आवाज नहीं करेगा। देखते हैं उसमें, वो तो है तो कैपेसिटर टाइप है, टेबलेट वाला नहीं जो भी।
Some participant has unmuted themselves. So Secretary Sir is not with us, but we thank Secretary Sir for his words, which gives appreciation for CPWD works, and we get encouragement for his kind words. Now we should move to technical session, and in technical session we have 6 presentations, and 2 presentations has been co-authored, so we have total 8 speakers. And our first speaker is Sri Rajneesh Karim. He is program director from CSE, and a brief introduction of Sri Rajneesh Karim has already been given by our ADG sir, so I will not waste much time in giving introduction again. I just want to say to our participants that they should remain muted, and if they want some questions, so they can type it in chat box so that we can get their questions and we can ask from our speakers. And for a speaker, we have allotted 25 minutes each, 20 minutes for their technical presentation and 5 minutes for question and answer session. So I will request all our present authors to stick to their timelines. And now I request Sri Rajneesh Karim ji to start his presentation.
किन लेवल तक के लोगों को पार्टिसिपेट करने के लिए कहा गया था?
Rajneesh Karim ji is available with us.
बोलो ना फोन करके
नहीं 125 आ चुके थे।
क्यों फोन बोलिए तो बैठ कर फोन करेंगे फिर क्या होगा?
हेलो, आपको आवाज आ रही है मेरी?
आ रही है आपकी आवाज, क्लियर आ रही है।
और प्रेजेंटेशन आपको विजिबल है सर?
हाँ जी, हाँ जी।
Okay, thank you very much, and good morning to all of you. And first of all, thanks to CPWD to give us extend an opportunity to present the work which we have been recently completing. I think this was one of the recent discussion with CPWD official, where I did mention that we have been working on a very live project on indigenous engineering solutions in construction. So CSC has been researching on this area, and and it's not because the the subject is very advanced and there are a lot of information in this. So I won't say that we have concluded this research, but we are in midway of the process of it. I'll present to you what all informations we have. And I think it goes in sync with what Secretary Saab as well as the DG Saab has already said, that indigenous needs to be promoted more. So the native informations and the information of these native technology becomes one of the important factors for us to intervene. So I'm changing the slide. Is it changing along as well over there?
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. So primarily in the past, in 2 decades or 3 decades back, we have been overrun with these kind of pictures which was there all across our town. But this picture is gradually changing now. So what we have done is while this lockdown was there, or COVID lockdowns, and we were restricted in the home, what we have done is we conducted a surveys of various towns through the RERA database to understand what is the penetration of new construction technology. So various towns, as I'm showing, Kolkata, Jaipur, Mohali, and all places we have been there to see that what kind of technological or the construction advancements are happening. Primarily, what it comes out as a result from there is that still we do have a burnt brick structures which are dominating. But when it comes to the major urban centers like Delhi NCR or even Kolkata and Bangalore, we do see that monolithic concrete structures are now making a lot of entry, and as well as do we have certain environmental green materials in terms of fly ash and AAC also coming along with it. So this is what is the landscape which is presented to us. But the situation is that we are talking about something which is indigenous, what belongs to the local roots and could be utilized. So where is that landscape is going to go? So for example, in this last 2-3 years, we have seen that there is a lot of migrants moved back to their parent locations, and the housing industry was also disturbed to great extent. But this poses a challenge as well as gives us an opportunity for us to recover, and recover in a green recovery way. So why green recovery? Because we have to now sit down and understand, because we were there in our housing and we understood why we were locked down at home. We understood that what works and what doesn't works in the kind of development which we are right now. So that poses a big question, and materials as well as the technology becomes one of the good answers for that. So in that, and as well as there is a lot of employment opportunity which is associated with these, with particularly with the housing as a sector in mind. So what we have done is we've just taken a overall that how this pandemic is affected, as well as the economic dislocation which has happened on humanitarian crisis. So how there are benefits which are there by which a green recovery can help. For example, Secretary Sir has already mentioned that climate change becomes one of the important intervention for us to get in. So improving the thermal comfort becomes one, livability condition becomes another one, and having maximizing the livelihood potential. So these 3 areas becomes one of the important areas and zones for us to intervene. So what we have done is we've taken focus area which is coming from West Bengal and Orissa, because there were like roughly around 5 to 6 states.
Have we lost his voice? क्या साउंड नहीं आ रही क्या?
Rajneesh ji, you are not audible. Rajneesh ji, you are not audible. Please rejoin again if you have issues. That may help.
फोन करके बोल दो, फोन करके बात कर लो.
We have some technical glitch. I think microphone of Rajneesh Sarin is not working.
मुझे लगता है प्रेजेंटेशन भी स्टक है ना, तो आगे बढ़ नहीं रहा, वरना स्लाइड तो बढ़ती है आगे.
Participants are requested to be patient and wait for a few minutes.
May we request Mr. Sarin to log in?
वहीं से कुछ इशू है?
रिकनेक्ट करना पड़ेगा प्रॉब्लम उनको फिर से.
नहीं सर, आप रिकनेक्ट हुए सर.
अब समझ.
Our online participants are requested to remain muted.
रजनीश सरीन दिख रहे हैं इसमें, रिकनेक्ट हुए दोबारा.
ऑडियो वीडियो दोनों नहीं आ रहा है सरीन साहब का.
सर वो लॉग आउट हो गए, उनको फिर से जुड़ना पड़ेगा और प्रेजेंटर फिर से बनाना पड़ेगा. लॉग आउट हो गए, वो प्रेजेंटर्स की लिस्ट में नहीं आ रहे.
ठीक ठीक ठीक, हम करते हैं.
We have lost connectivity to our speaker Rajneesh Sarin, so we will take him later on, and we are going to proceed with Professor Chandan Ghosh, and we are trying to get him on board. So please wait for 1-2 minutes. प्रोफेसर चंदन घोष जी,
अनम्यूट करने को बोलो पहले तो.
या हो गया. हाँ अब ठीक है.
प्रेजेंट
Yes,
करने
sir, yes,
को.
sir.
He can start his presentation.
Okay.
Please start your presentation.
Okay. Thank you for this one-day occasion on behalf of NIDM, National Institute of Disaster Management, presently located at Sector 29, Rohini. I'm presenting here, just sharing my presentation. What is this? Yeah. Okay.
Yeah.
Yeah. Okay. It is seen now.
Yes, we can see it. Please continue.
Okay. So let me speak in English or Hindi. मिला के बोलें.
You wish, sir.
Okay.
सर मिला के बोलिए सर मिला
मिला के बोले. हाँ, इतना अंग्रेजी क्यों बोलना है? हाँ, जब हिंदी में इतना अपनापन होता है. हाँ, तो ओके. तो मेरा जो टॉपिक है, ऑफ कोर्स यू आर ऑल इंजीनियर, कोई ऐसा कुछ नया कुछ नहीं है, but we all have been so busy, so much, especially civil engineering, especially dealing with the dam, probably the oldest thing that civil engineers have handled after becoming engineer, or even before we existed as a civil engineering discipline. Dams were there for the survival of the civilization, and many uses are there, and of course a lot of controversies are also there. But my thing is that disaster paradigm and damage assessment, I take it to that where we are leading to this mass scale construction, and what portion we as civil engineering fraternity, we do so passionately, again we ignore so impassionately. So in that respect, I will take the things to the paradigm, the disaster paradigm, even though we have got the code, manual, SOP, guideline, and practical examples, and then there are pilot study, performance study, checking, testing, so many areas of say specialization that come up, like in the medical profession also, but still things happen. And at the same time, when we see just for the last 5 decades, there are certain agencies, both in India and abroad, they record that year-wise, just only, I'm not going into those details, listing out that what are the disaster or what are the hazard that we have experienced, year-wise, that how they are increasing. And what is the major part is the landslide. So I will take this into the landslide, today's presentation, especially while talking about the nature-based solution, and DRR is a very, very common word, disaster risk reduction. So, but whether this is a direct indicator of our progress and development that we keep in records, or we are living in the comfortness that we are enjoying, even with the development of so many technologies and know-how, including communication, that which we are doing here online. So, but when we are recording in respect of this thing, whether it is mass movement, volcanic activity, wildfire throughout the globe, where it is leading to, where we stand, and what are the health perspective that we have to look at about our infrastructure. That aspect I would like to highlight. Not only that, while storing water, this is the most conventional way, storing huge amount of water, but we know that what problems that we are facing in storing them, causing environmental problems and many other things. And in case of earthquake, what are going to happen? Even though civil engineering fraternity, especially geotechnology, has a lot of things that we know how perfectly to design a dam, and that is what that we have been perfected as a civil engineer, that we give almost 100% attention to this portion, and similarly not so much attention to whatever that is not possible also in most of the cases when such a robust thing is there. But alternatively, with the modern day living, with the such kind of geomembrane or geosynthetics, petroleum byproducts that are available, how much water we can store? It is from 1,000 liter of, like in our rooftop that we can keep. Even with this, we can make the complete storage of water at any part of the country, whether it is hilly area, whether it is inside the ocean, where it is called flexible storage. Now, these days, we have recognized the use of geomembrane in storing water or pond or fish pond or something in many of the farmhouse. But we are bringing these things now elaborate manner when such kind of construction is almost not possible these days. So alternative we are searching out, and many alternatives are there. And not that we have to make this, or we can store water in this manner also. So while we talk of the disaster risk reduction, then there are many other alternatives. We as a civil engineer, along with the community, depending on the necessity and arrangement, where low cost, it is definitely low cost, minimum effort, not a gigantic effort of like this. So we must go into some kind of micro storage like this or like this before we take up the disaster risk reduction into our life stream. Despite that, we have been now, whole world is going into market intelligence, and what are the trends that we have been identifying. In fact, these days, well, most of our engineering young students, they are moving towards, computer and artificial intelligence, big data, blockchain, connectivity, digitalization. So this is a software, all a total. But when we talk about the hardware like this, then we are not way behind, but we have to make ourselves. हमें जो है इसका चेतना जो है, even though we have we have done, we are making 100+ story or monuments and many things that we are making. We have to come in. Before going to show some of the glimpses of that, what has gone wrong or what might not go wrong, what we do, like this is an idea. Every year, of course, before we used to have some kind of mock drill or some kind of disaster or building pull-ups. We make it, and then we have a lot of people here. They come with an IDM cap here, you see. So we do a lot of awareness in the Pragati Maidan, which is getting now modernized now. So we all know, but having such kind of practice and then awareing people has been the hallmark of awareness generation across the country by NIDM and many other institutions. But what is happening that we are not keeping, as I said, that while the backup by these things, backup by this kind of technique has not yet caught the attention, that it is simply a show, but how these things can be replicated, data can be taken, and sensors can be placed, and so that our search and rescue becomes more efficient. That part, these kind of things are getting, means IoT devices are getting more and more important, whether it is fire, whether it is pull-ups, whether it is monitoring, health monitoring, and other things. So just to show some of the things, Feni, Cyclone Foni or Feni, you can say 2019, the airport was there, then it got tottered, not because that airport has failed, just because some of the items that which we have to allow to go like this when torrential rain as well as wind is there more than 200 kilometers. So we have to take such kind of things into our design that we cannot make completely a system here, such kind of soft or non-structural material resilient to 200 kilometers or more than that speed that of the West. So we have to allow them to fail like this, or we also, but we cannot allow things inside the airport fail in this manner. So for that, what kind of flexible design to be made? Still, we have not yet perfected in our civil engineering domain. So after few months or after few days, then we restore it back. But by that time, we lost many things. So there is no such assessment except an amount that, okay, 1 month we could not operate, but who takes the burden of that refurbishing it to bring it back after 1 month or after a few hours or after 3 days? So what kind of effort to be made in such kind of, coming back to normal in the DRR, disaster risk reduction? Still, it has not come into the limelight into our civil engineering practices, especially the damage assessment, not only pointing out the figure that 1400 crore we have lost, but what are the methodology that we can reduce by making simulations and other things, so that during 200 kilometer cyclonic speed, we have to keep the airport shut, or we have to allow that that we cannot change the direction of the wind, but we can facilitate that wind passing through the wind means 200 kilometer torrential rains and wind passing through the airport. That kind of computer simulation these days are plenty are available, but we are yet to incorporate those things in practice. Rather, we close the airport or such kind of facility whenever we get weather or such kind of warning. That have to take it. Whenever there is an urban flood, how many of us have yet adopted that not stopping water this much, but almost 1 meter or 3 feet, 4 feet, in this way, with such kind of measures? It is very far and few and far between still adopting in this. These are not foreign material, but it is being shown in Australia, Austria, or other country. So many of the urban floods that even in September that we have faced, waterlogging and other things, even in the underpass that we have experienced, huge traffic jams and other things. Many of these devices are now flooding the market. So, but we have to adopt such kind of protections also of the facilities, which is beyond that only designing a building construction as per earthquake resistance or other things. So such kind of things still, of course, there are certain projects have been done, but we have to bring it into the streamline this kind of measures also, along with the salient measures following the code or national building code. So even in flood, like Kochi airport, Kochi, a 5-star platinum rated airport, got flooded, not because that it rained here so much. It didn't rain so much because some of the dam, they have to release their water with not much of synchronization, which dam is the gate to be open, which is not to be open. Here again comes that surveillance as well as IoT devices now these days, that when to release and what is the in what way that it can be channeled out so that we can come back. It took more than 24 days, 14 days to come back to this operation. By that time, we have lost many things. So that gives a way to infrastructure report card. But since 1988 to 2021, in America, we have not yet started, although there are certain exercises being done. Data is there, efforts are going on in the country, but systematically, American Society of Civil Engineers, that they have taken this say 16 such parameters and rated them as we grade our school children or even universities. C, none is above C, above B. So what are the progress that they have made or over the years because of the previous report, like every 3 years, 4 years they do. So what is the overall grade is D+. So which you can imagine that the civil engineering fraternity with so many organizations, so many professional organizations that where we feel proud of that we are the custodian of making our infrastructure, making tunnels and everything. But when we go for grading, when we go for systematically that how their performance are going on, so we must emphasize ourselves to check that what is the health conditions of the dam, bridges, aviation, parks or ports, rails and other things before. Like many of the things we go to the court to decide, but it is an engineer's job, it is a technological things, not everything that our court or law can decide, but when it is the matter of infrastructure, safety and their health, it is we have to take care, like the doctors take care of the patients. Now, nature has given us a lot of lessons that which we are forgetting and we are still allowing. Like nobody knew that this is the weakest part even if it is a temple-like structure like this, more than 300, 400 years. But before Bhuj earthquake, it was there. And we all know, you have got all record. After Bhuj earthquake, here it is broken. So this is a steel. But what is happening, what has not been thought of so far, but we have to. Yet we do allow buildings plan. We pass the building plan in our city with mandatory steel for parking, with no such performance satisfaction, and it is being silent in the code also. And we are showing that we are as if that helpless when such kind of lessons is there, which is thousands and thousands of building with steel they have floored. But there are ways to take care of the steels, even if it is existing or new one, which we have not yet implemented in our country's context. And not only that, as a civil engineer, we look so much what is seen over ground, but what happens in the soil, I would like to highlight few slides over this only. It is due to the this Kandla port, one of the building, you see that how it has tilted. And what is the major reason? Most of the cases that whenever disaster happen or flood or drought or something happens, we simply see that how much more expenditure is to be made and in how quickly that we are going to make it all right. But what deprives us, or we are not emphasizing to look into the details that what has caused, what is the back analysis, or what has really caused such kind of tilts and other things. So there are many examples that if we know the cause, then we can go for the design. Otherwise, we cannot. Like this is in Sichuan earthquake in China. This is being taken off, this portion. So why and how it is taken off? Very few such case studies are reported. But how, if in liquefaction prone area, that what kind of study, research, physical testing to be done in our laboratory? This is a centrifuge test being done. There are, of course, we have in IIT Bombay, but there are certain tests which recreate the conditions that happen in case of like this kind of breach, and then see that how liquefied soil has made a devastating effect onto our bridges and structure. So such kind of research to our research laboratory, CSIR laboratory or IIT, these are only going in a theoretical domain. So to the practical engineers from practically those who are in practice, our appeal is to combine this practice and knowledge that available and being nurtured toward the globe to solve this problem and design. Or otherwise, the kind of structure that we are making. Okay, I think I have some limited time.
Time get now.
Okay, 5 minutes more.
Yeah, please wind up. 5
Okay,
minutes.
okay.
Thank you.
Okay, okay. So these are the things that in 1995 Kobe earthquake has caused such kind of failure. And it is not unknown, but you know that how we are propagating such kind of structure in the earthquake prone area in the country. No one can guarantee. I can say that no engineer can guarantee the safety of such things in case of earthquake. How many piles that we are putting up, 5, 6, 10, 20, that is not going to guarantee in an earthquake of the safety of this thing. If it is safe, we will say that earthquake has avoided because resonance has not occurred. But with the kind of inverted pendulum that we do, such kind of thing, when intensity 7 or 8 or 9, when it comes, it is surely they are going to create such kind of havoc things in our elevated expressways and other things. Lessons are known. Everybody knows about that. But what is important that why this bridge failed in 1964, again, they have gone into the systematic investigation that how it has went wrong. Already I have shown that liquefaction, lateral, spreading and other things which was studied in 1964, and it has opened up a huge area of research in geotechnical and geotechnical earthquake engineering. This bridge fails in June in Chhattisgarh, and how it has failed because of the monsoonal flow. If we make a structure like this and we don't take care of this flow and scouring all these things here by conventional way, then probably we are failing our duty. by not taking of its health while it is functioning. So, but when earthquake creates such kind of failure, then what are the retrofitting measures, strengthening measures, safety measures of the existing one have to be taken? It is some of the example taken even more than 2 decades. When water is entering, like in flood, that we can take up this thing. For this, no engineering is required. No engineering is required to make such kind of protections of our facility, or even making a road, live during that inundation is there by making geotube. And these are the this kind of measures we can take rather than shifting the entire operations of the hospital. So we do not know many of the things that whatever is happening, geology, geomorphology, they have been doing, but what we are interested about the overground only. So in that case, what is happening that I want to give 1-2 slides is that this is the happened due to the heavy rainfall in Coorg area, Madikeri in Karnataka, that this is the condition of the slide. Only using local community, whatever grass has been placed, लोग खसखस बोलते हैं हम नॉर्थ इंडिया में, और भी रमाचम बोलते हैं, हम कुश बोलते हैं बंगाल में. तो इसको हमने जाकर के दिसंबर 2019 को अप्लाई किया. 6 महीने के अंदर it has restored with no effect and no cost and nothing. The community has taken care. So this is that grass where it has got many multiferous. It is a revolutionized our way of thinking to look into the nature, the way that like nature-based solutions. So it has got, you see, it can grow in pH 3 to 10. It can be minus 15 degree to 55 degree. Rainfall, any rainfall it can. So many such things are there. And some of the applications that it can grow within a year or two, even 10 feet, 11 feet, 12 feet tak ho sakta hai. We can see that viable difference in the slope more than 60 degree. Whereas we make our embankment design 1:2 or 1.5 or something like that. It is grass that for that we do not know any mechanics to explain how nature is able to give such kind of steep slope, which is the main key for stabilizing most of our roads, which I could say. Here also we don't know any theory that how this is being saved or it is functioning for more than 4 decades in our Hindustan-Tibet road. So many of the things we do without knowing, but still we believe more in the God. But still, we हमें इस तरह से ईश्वर की याद करने वाला जो गैप है, इधर जो हम इस तरह से जो हम नेचर से ले रहे हैं, इसमें काफी कुछ हमें सोचना है. We make the road in this manner, we leave it, and we put some kind of wrong kind of grass here in the name of stabilization. But right kind of grass, like vetiver grass, they can stabilize. We make our road in this way and we make such kind of heavy retaining wall. Whereas this kind of things measures is good enough to take care for the lifetime. And we make such kind of things that we can change this to this in this manner by these natural techniques. Anyway, there are many such examples, many in India and abroad, but we have to take it. And we are still making the road in this manner, but we can put the grass here itself. Okay. So these are the natural way, which is costly, labor intensive. We are not able to do that. But these are the real surgery that Japan can do. They have made it. But what we are doing in this manner, which is not at all an engineering way of stabilizing a slope. Whereas engineering technique is defined here in the textbook, we do not adopt much. So anyway, I would like to say that there are many ways that without retaining wall, with nature's own way, we can make many things possible with looking at our country's economy and the way that we can change using natural technique. But there are failed way also, not because the grass has failed. I have shown you many examples. If water is not given in the first 2 weeks, it will surely die out. So anyway, there are ways to hydroseeding, which are also being applied many places. We can grow the grass wherever we want. And we have this technique now being indigenized now in the country, though it is made in USA, but we can grow grass wherever we want with the right mixture of the ingredients. And this research has not yet started in the country. So anyway, let me come to the end. We can make such kind of stabilization by vertical grass as well, where we spend crores. And this is in India, in Guwahati. And these are various applications that we have made it possible. We can check, we do research also on this, which vertical grass will survive because it is a natural material. There are advantages, there are some disadvantages also, but it is a perennial and it has to be done just after the rainfall. And with the last slide is that river erosions and other things that we look at using our Manrega workers, we can make it in this manner. Many such projects are being taken in the state of West Bengal and also in the state of, say, Karnataka. Let us take it and march ahead with a natural way of taking many of the problems that we are facing in a right manner in order to put a footprint to our disaster risk reduction measures Sendai framework. Thank you.
Thank you. So now Mr. Anish Sareen will complete his presentation.
He's on me.
Yes, sir. I'm there. I'm just trying to share my slides now.
Please continue.
Is there any question in chat box?
क्वेश्चन आखिर में ले लें, वो चैट में लेके ना, क्वेश्चन बीच में करेंगे तो फिर बड़ा मुश्किल हो जाएगा.
Okay, sir. Okay. So we thank Dr. Chandan Ghosh for his learned assessment of disaster housing forces and a solution for some of the disaster in a cost-effective way. And now Sri Rajneesh Sareen has
Again,
so we request Sri Rajneesh Sareen ji to complete the presentation, which has been interrupted by some technical glitch.
Right, sir. So is the slides now visible and I'm audible to you?
Yeah.
Yes.
Okay, perfect. So I just parked the information that what exactly is happening. The self-construction dominates right now under housing. So that means even in the 70% almost in PMAY is also self-construction. Now this self-construction is mostly supported by informal sector or small enterprises, which requires a lot of hand-holding in this. Then green recovery pitch I've already given that why we need green recovery, because it is indigenous, labor intensive also to great extent, because though we get the speed also, but we get local materials. So green, local and self-reliant, which is the topic of the today webinar as well. So, and then we do have new advancement in terms of financing, which is there with us. Like for example, the fifth vertical, which is the rental housing, which has been recently introduced. There are new ways of looking at the things in terms of technical innovation grants, as well as viability gap funding are being also extended to these dimensions. So these are some of the mixes which are available. To bring up a hot cup of tea from all this, we need to mix and do a jugglery for all this. So what we have done is we got a review of all the PMAY project, done a lot of census penetration data to understand what is the materials, how they are located, how green they are, and what are the labor intensity which is required. And then we have done the expectation mapping of the public to understand that what is the expectation people have there in mind, and as well as mapping where are those institutions which can help to map the skill which is required to bring these kind of projects on ground. So all these database are being presented. So for example, in this, we see that a lot of penetration of other items other than brick. We do have other materials which are indigenous and are popular in our census data, as well as which roofing materials. One was on a wall, this was in a roof. Similarly, we have done for Pradhan Mantri Awas Yojana Urban, specifically under AHP as well as the beneficiary-led construction. We do see that there is a change of landscape between two. The materials, for example, which makes a dominance under AHP and the one which make under BLC are totally two different sets of material choices which is there. Similarly, when you go to Pradhan Mantri Awas Yojana Gramin, you will find a new landscape of material mix which is coming. So that means moment you become more local, you become more centric, your material choices and those compositions are changing along with that. So what we have done is we have done a repository of material across the India to understand where these materials which are native and are being used. So for example, the one which I've shown you is for walls, and this is for primarily for the roofs. So various such materials technology pan across India are now available. So which like for example, if I look at the graph of Orissa specifically, so what we have done is we have taken the wall technologies, roof technology, specifically mentioning their name and as well as their presence, which is there across in all the districts which is there. So this goes as a ready reckoner for anybody who's trying to, like for example, CPWD is looking for a project which has to be done with indigenous technologies. Immediately these kind of information and repository becomes one of the parameters to pick up, okay, what is available, what exactly is more popular and what I need to. So for example, Orissa becomes one of the important state because it has a prominent or dominance of SC/ST population which is there. So when you look at the tribes, for example, tribes have their own ways of making materials, and they have been more like, for example, the presentation which was there on disaster. So all our technology, for example, were done in such a way that they can adapt to the kind of disaster which was there. Like, for example, the earthquake prominence which is there, or for example, the local temperature and conditions. These materials, particularly tribes, adopted accordingly. So, but these require a retrofit now. Like, you cannot use these technologies straight away into a combination of the new world. So that means the traditional and the neo-sustainable, these needs to blend together with this. So these are some of the compendiums which we've done. So what we have identified around or 30 technologies, which are traditional, neo, as well as the alternate, many of them, with the one which are making presence now into the self-built housing. So, for example, there are 45 technologies or more than that which has been identified by BNTPC, but mostly they are being used for high-rise constructions. But the one which is primarily being used for low-rise, we have just taken those technologies also into it. So, we are developing a kind of documentary technology documentation samples also, where you understand that what goes into the technology, what are the construction details, and according to which these manuals or basically the kind of training materials and things will also come up with this. So every technology is being elaborated into further dimensions of it. Now, the other area for us to intervene or look at is, like, for example, that how is this technologies are being taken up in terms of, like, for example, their ancestral knowledge, or is there institutions or organization which are working, because you require this. Otherwise, you will not get a desired labor also which is coming in this. So what we have done, for example, in case of Orissa, we've done institutional analysis to understand, as well as the national institutions, for example, the CBRI, BMTPC, DA, HUDCO and all, what have we been doing in terms of various structures, how we're helping these states. And then we come up with even the training centers which are built across the India, which are like really pioneering and bringing these you can say the native technology and promoting them into the desert. Now, do we have information of what are the technology? We have information of where are the skill centers available. Now we have to look at the demand. So we've done the market assessment to understand that is there a demand for material? People do recognize these materials or not? So what we understood, people are aware about the material. People are looking, for example, people are saying that they need government policies to push this. They are looking at how this landscape will change when you have more material availability, you have more skilled available skills or skilled labor available, as well as that they need to be more aware about the cost part of it. So the cost, the kind of availability of skill and all these things becomes one of, and people are ready to spend money. So we have checked with them, they're almost like they're ready to spend even up to 10%, almost 40% of the respondent, which is more around 600 sample which we've taken. So they are responding to this. And then similarly, for example, people, when they make their own houses, they are willing to construct into a traditional or a construction or a neoclassical way, which is there. So what we have done is in order to solve and resolve this, we're bringing up the dashboard, which is going to be a free dashboard available for people. Like, for example, in West, you pick up the state, you look at the kind of roof, fenestration or walls you are looking at. So automatically this dashboard will start populating the technologies in front of you, that these are the one. You pick up any of the typology, then moment you click on the technology, you get the video, audio, and the write-up setup for it. The write-up, I have given you a sample that how. So these are the ways when we connect these dots together. So we need to connect these dots because these informations are there. We have been using, because I think there are many projects where CPWD has used the native technologies, specifically when the recent in terms of intervention with regard to thermal comforts and all, we've tried to blend them together with our new ways of techniques, the way we are doing now, the new type of setups as well, and blended those old philosophies and methodologies into it. So this becomes one of the very ready reckoner, which currently I think we lack a lot of information with regard to it. So we just made a little dashboard available. We will be soon bringing it up, that where you select the budget, you select the kind of how that house should look like to you. It populate the kind of technology according to your region and give it to you that, okay, this is the way, these are the costs, this is the way the things are. Like, for example, this eco homes or whatever we try to bring up as a new title for it, so that at least there is a information and a database available to people. So what is the final submission from our end is that there is a great opportunity for skilling on climate appropriate materials, because why it's easy, it is like something which is very native, which is passed from generation to generation. It's a traditional knowledge, but it needs to be brought into frame, because effectively what will happen is this is the way that people are going to make their life more sustainable and more equitable, coming the way the thought processes. Otherwise, we remain centric to the centers. Like, for example, what we have seen, that labor movement, there was a first hit of any disaster, the migrants started moving back to the towns, which because the cities could not afford them, both for infrastructure as well as kind of appropriate economics which they required at that time. Then there is a plenty of knowledge resource on climate appropriate materials which needs to be tapped in. Like, whatever resources we are taking, it's not that every time CSC is researching. There are a lot of informations from national institutions as well as from CPWD which is available. We are plugging those dots together. Then the fast switch towards the modern technology, this needs to be regulated properly. For example, if we are switching from brick to concrete, definitely the U values changes to a great extent. So we need to see that when we do the switch, the switch has to be in a very responsible manner. Otherwise, what will happen is we may make fast construction, but we may lose onto environment or to the climate to a great extent. Then there is a lot of knowledge which is there with informal sector, which needs to be mobilized, so that this becomes a blending opportunity available. And we know that we are carrying our old historical or the way of we made our houses into the new form of the technology which are coming up as a sandwich or the combo offers which could be available in this. With this, I hand it over back to the organizer, and thank you so much for giving me an opportunity to present.
Thank you, Mr. Taking the presentation well within the time. And as our register had said that we will take question and answer session in the end. And for the third presentation, we have Dr. Subodh Pathak and Sri N.K. Sharma ji. And topic of their presentation is Indigenous Engineering Solutions in Construction, Green Building and Sustainability. And Ashutosh Pathak sir is present in this conference room, and he will give his presentation from here only. So I request him to start his presentation.
अनम्यूट करो अनम्यूट करो ऑडियो ऑन कर लो आपको ऑडियो बंद है सर, अभी भी बंद है।
Good morning. Begin with, I hope I am audible.
अनम्यूट कहाँ कराया है? अनम्यूट कराइए।
Good morning. Begin with thanking National CPWD Academy for giving me this opportunity to speak and I also thank Rajneesh Sarin Sahab and the Sandan Board for setting the appropriate kind of a context so that I can now be more aware as the leaders will be aware. I have been
उधर बंदी दिखा
working
रहा है।
with and I'm also visiting National CPWD Academy as a routine, and I'll be more direct. And the topic of the presentation is indigenous engineering solutions in infrastructure, rebuilding and sustainability. So I start with a very positive note, right? So if we have rapidly developed few of the technologies. Okay? For example, the Trinity of Jonathan Radwar and Mobile Jam or Jam, they have revolutionized. I think every mission, everything with governance, be it governance or be it anything else, it has revolutionized many things. And similarly, India has
मोहम्मद दिल्ली जाओ।
ahead of many developed countries as far as these areas are concerned. And similarly, our space program, it has been a great success, and no one can meet its cost effectiveness. So now I have a question. So why these spectacular successes, say JAM and space, why they have not happened in the construction, right? This is the question. Okay, maybe DMRC is an exception, and I have deliberately put that in the brackets. Okay, so at least the understanding of us, say, of the authors, is that both say IT sector and the space sector, they have developed after our independence. We were zero before independence, and it has developed after that. And say all engineers and all the best of the best have come up, and we have shown that we are even better than other countries, right? So now I think say excellence in construction sector is even more important. And as I pointed out, it has not happened, right? So the understanding is that I think it has something to do with our historical underpinning. So the construction industry developed as a kind of a colonial offshoot, and CPWD has been a very important part in the historical development. And many times, say excellence apart, we were required to say provide employment, right? There are many examples for that. And say why it has happened in the DMRC? Maybe because it is supported by a different act of the parliament, right? So it has the systems are different, right? So this webinar is about, say, Atmanirbhar Bharat, and systems are one of the 5 pillars, right? And infrastructure is another. Now, I'm coming to a very important distinction that the construction sector is having. Say, unlike, say, our successes are very laudable and very great, but the construction's impact on sustainability sector is enormous, right? So now, in the changed world scenario, so I think the whole humanity has decided to fight against the global warming and climate change. And one of the important aspects of controlling global warming and sustainability that is required is that we limit the global warming to 1.5 degrees, right, above the pre-industrial systems. And our urban systems require transformation. I think in our, say, Professor Chandan Ghosh adequately, say, reflected on that our urban systems require not just some nudge, but total transformation. Now, how we are going to tackle it, right? So, countries put forward mitigation commitments in the form of nationally determined contributions, right? And our latest report, the India third biennial update report to the United Nations Framework Convention on Climate Change, that states that the emission intensity of India's GDP has reduced by 25% over a period of 2005 and 2016, right? And say if we compare what we had committed, say in 2015, our Prime Minister had gone, and at that time it was thought that whatever we are committing is very ambitious, and it was. As a professional, we thought that whatever India has committed is very ambitious. So what we had committed in, say, quantifiable terms, we had committed that by 2030, we would be reducing our, say, GDP, this thing by 30 to 35%. And only in 2016, we have reduced the GDP, the emission intensity per unit of GDP by 25%. So we are exceeding it. We are exceeding whatever we thought was very ambitious that time. And again, I think it is again a very laudable thing. But I think this is makes us go beyond 2.5, 2 degrees Celsius, right? Which was that we are committed, we are overachieving our NTCs, but that is not adequate. Similarly, here I would like to point out that building energy policies are very important aspect in India's mitigation industry strategy, and that is why it is so important that we say transform our construction sector. So now I think I must mention on sustainable development goals as well.
ये अभी तुमने कौन सा ब्रश लिया?
Yeah. So I think this is a poster which is people would be, say, viewing it for many times. I think if they have not viewed, I think they must note them. Okay. So these are the 17 goals which the humanity has adopted. I think more than 98% of the humanity's leaders, say when they met in 2015-16, they have committed to these 17 sustainable development goals. And out of these, the construction sector plays a very important role in all the 17. but importantly, it plays very critical role in, say, SDG 11, which is sustainable cities and communities, and climate action, goal number 13, clean water and sanitation, goal number 6, and responsible consumption and production, goal number 12, and in, say, increased industry, innovation and infrastructure, goal number 9, and of course, life on the land, right? So these, I think it is the current humanities thinking, and it is not, say, only limited to the developed or developing countries. It is universal, and the construction sector is very, very vital to all these. Now, coming to the green building certifications. Okay, so building sector has a very high impact on, say, sustainability, and green building certifications is one of the ways. Okay, so and MEP sector, subsector has already very actively engaged in this green building certifications, and say it is mostly driven by the big trade associations and an NGO. In India, specifically, it is, say, one of the most popular green rating comes from the CII. Another one comes from ASSOCHAM. And again, the GRIHA is being run by the NGO, right? But here is a point. Even the, say, GRIHA, which is run by an NGO, they have some kind of a list of approved materials, and you can achieve a lot of points by using those. Okay, and say all the green certifications are based on our national standards. It is National Building Code or Energy Conservation Building Code. Basically, these are the two standards that are somehow reflected in the ratings. Okay, but many times it so happens that because, say, stakeholding is very important, and as the stakeholders are, say, trade associations, they tend to promote their own products. But I think the department like CPWD, they have their own transdisciplinary teams. They say they recruit best of the architects and best of the engineers, and now recently they have come up with the initiatives, right? And I would say it would be very fascinating to see how it turns up and how it comes up, and it addresses the sustainable development goals and our nationally determined contributions to the United Nations directly. I think they have already the foundational knowledge given by the existing, say, GRIHA, maybe IGBC or whatever, and now it can be built upon, and probably they can address our national, say, initiatives directly. Now, how CPWD leverage the construction industry is the question. Okay. So our say suggestion is that we must not limit ourselves to the construction itself, and we should, say, invite and, say, proactively get into the inputs from the other industries, right? It may be, say, success in the space sector, or it may be success in the, say, GEM Trinity or IT sector. We must, say, learn from them, and then utilizing the extensive research done at national and research laboratories, academic institutions, and the BMTPC. Okay, so wonderful, great research have been done by, say, isolated by these institutions, and we must utilize, right? They have been utilized partly, but I think we need to, say, think big, and maybe, say, utilize and build over on the great work done by our institutions. Okay. And yeah, now coming, how can it be done? I pointed out in the beginning, it has not been done. But so how do we do? So our suggestion is that the say like any other traditional sectors, we are say divided in silos. So breaking silos boundaries and using the true intents of our national building code. Okay. So I think many of you, rather all of you must be aware that in 2005, Part 0 was introduced in our national building code. Okay. That stated that say you must have transdisciplinary teams. In interdisciplinary, you must have those teams, and they should be, say, from the very beginning, from the inception of the project, they must be in place. But unfortunately, it has not happened. Okay. So I think that is one. And yes, now coming back again to the indigenous engineering solutions. Okay. So here I think it is important that in the Atmanirbhar Bharat, infrastructure is one of the 5 pillars. Okay. So it was say along with economy, right, systems, and demography and demand. Infrastructure is one of the 5 pillars, and CPWD can play a very big role in say creating a kind of an infrastructure which supports sustainability. Okay. Now, whatever is included in our widely acceptable specifications. Okay. I'll take another case study towards the end. We will take a case study that how once a thing comes into our specifications, schedule of rate, and the routine practice, then it becomes a kind of it is then a cakewalk. So, and say green buildings, they have great examples, but I think they remain demos. Okay, right? Like say, and a norm. Now I think gradually, an enclosed buildings they have become a norm, and which may not be desirable. Okay, and now the bottom line of government as a policy driver would be involving a construction field professional in the building innovations and research process. I think the main point is that why it has not happened, why the research has not been translated into the practice, right? So our say hypothesis or maybe our guess is that we have not involved the professionals, the field professionals in the research. Okay, so we both the authors of this paper were say in the inception training of the architects and engineers, and what we know, we took the professionals, the architects and engineers, to various research institutions. So when we went to Dehradun, say there are two or three very prestigious research institutions, FRI, then there is IIT Roorkee, and then there is CBRI. Okay, so what we saw in FRI was, say, there were field professionals there, along working in close coordination with the scientists and other transdisciplinary people. Okay, but unlike FRI, in CBRI and IIT Roorkee, there were academicians and scientists. Okay, so I think the message here is that probably it is our good research work is not translated into the field because we have not employed our professionals into the research. And I think this is the final message. So ultimately, the construction industry has to move into a circular economy. Okay, unlike say mining and then processing and then dumping into the waste, we have to get into this mode. But we are far away. So we are proposing a kind of a system that we start, say, inducting professionals, field professionals into the research, which would generate data, and that would come, say, again, data has to be analyzed and say inputted with the transdisciplinary research, not simply say we have done a lot of good work, and the CPWD especially has been involved in doing a lot of great work, but say it is in isolation. Okay, I think my co-author will come up on this later in a better way, and what we do is to widen our horizon and examine it through transdisciplinary research, and then which will result in the innovative construction practices and to be transferred to the building construction codes. And again, new parameters will come, which will give more data, and this cycle would be running all through, and which will ultimately lead to the our circular economy. So I think we again come back to the lessons learned, and lessons learned would be about say our successes in the past. Okay, so I would request my co-author of this paper, Shri Manoj Sharma ji, to take over from here and say complement whatever has been said, and so I request Manoj Sharma ji.
Thank you, Mr. Pathak. I'm happy to be a part of this conference, and I'm thankful to Academy for giving me an opportunity to present this part of the paper. Basically, what Mr. Sareen has mentioned, we have to integrate the appropriate technologies, yeah, whatever conventional things we had, and improvise those things to suit our contemporary requirements. So CPWD, as I have an opportunity to work in CSQ unit. In our schedule of rates, we have introduced innovative items so that inhibitions in the government organizations is removed. Because this acceptance in the schedule of rates find wider acceptance in private as well as in public sector undertakings. So now it has broken the barrier for entry. After these new items are incorporated, they have been put in use, and the responsibility now lies on the field units to give the feedback on the performance of these new innovations, so that the data can generate some, say, interrelationship with other, say, functional use, and how it can be related with the other transdisciplinary fields. For example, I'll say that material sciences is a crucial part of it. So how material sciences is developing and how it can be interrelated and used in our civil engineering works. In rehabilitation of the buildings, we are all familiar that we use, say, Kevlar kind of fiber or this other fibers, etc., to strengthen the concrete, to avoid the shrinkages and all those things. So what we can do is, whatever data we are generating, it has to feed our innovation, keeping all transdisciplinary things, and then provide basis after analysis for our building codes. And once it has been incorporated in our building codes, it can be taken to our say field and our schedules and all those things. And then again, this whole cycle can move in a circular fashion. So I feel the parameter will have to be laid down, like we have already committed to the international community. So this accelerating our processes in line with the net zero building kind of things will be a good starting point in my opinion. And the problem remains is that whatever good work we do, we are not taking lessons out of those good works and trying to learn from those things. I'll narrate, in fact, there was some minor slip on the part of the introducer. I have been associated with the Indira Paryavaran Bhavan, not Jawahar Bhavan. And that was probably the first net zero building in any government or organization. And we have opportunity to visit several, say, contemporary works, including your Sizzlon One Earth work, which was supposed to be the only net zero building at that point of time. And they were also producing only 5% at site. Whereas in Indira Paryavaran Bhavan, we targeted 100%. And this building was completed in 2014. 7 years has passed, but number of papers has also come up. But whatever lesson we have taken out of those particular experience are not yet documented, I'll say. So I feel that if the chain is broken in data gathering and processing, then probably we will not be able to move forward. So we have to have a institutional framework, a system, what Prime Minister has mentioned in 5 pillars. So there we have to create an environment where this data is generated, artificial intelligence is used, and then it is provide an input to the, say, developmental loop. And I am happy that CPWD has taken a step in this direction. The process was started long back about this ERP things, and there we are moving in the right direction. Hopefully in the near future we will be able to use artificial intelligence as and this IT infrastructure to boost development in this area. Thank you very much.
Thank you, sir. I thank both the speakers for their thought-provoking paper. Sustainable and green building, and simultaneously it should be world class. We have next speaker, Dr. Rajiv Goel, and he will be giving presentation on monolithic concrete construction system using aluminum formula. So I request Sri Rajiv Goel sir to start his presentation. Is he connected?
Yes, sir. Please share your PPT, sir.
Yes, just a moment. Why it is not coming? The sharing option is not coming.
नहीं सर, I have made you presenter, sir. सर लीव और माइक्रोफोन के बीच में जो एरो मार्क है अपवार्ड, उससे शेयर कीजिए सर.
अभी आया क्या?
यस सर, यस सर. प्रेजेंट पीपीटी मोड में कीजिए.
Okay. Is it visible?
Yes sir, yes sir.
नमस्कार, मैं राजीव गोयल हूँ और मैं आज बहुत ही प्रसन्न हूँ कि मुझे मेरे सबसे पहले डिपार्टमेंट सेंट्रल पीडब्ल्यूडी ने आज इस आज़ादी के महोत्सव के अवसर पर एक प्रेजेंटेशन करने के लिए बुलाया है। और मेरे करियर में मैंने सबसे पहले CPWD को ही ज्वाइन किया था, जिसे मैंने सिर्फ 1-2 साल बाद ही छोड़ दिया था बिकॉज मेरा सिलेक्शन ग्रुप ए सर्विसेज में हो गया था। उसके बाद मैं बहुत बार नेशनल एकेडमी ऑफ CPWD एकेडमी में लेक्चर लेने जाता रहा हूँ, लेकिन आज इस आज़ादी के महोत्सव पर आप लोगों ने मुझे बुलाया है, इसके लिए मैं बहुत ही थैंकफुल हूँ आप लोगों का। आज मेरा जो सब्जेक्ट है वो है मोनोलिथिक कंक्रीट कंस्ट्रक्शन यूजिंग एल्यूमिनियम फॉर्मवर्क सिस्टम्स। आज हम लोग आजकल मोनोलिथिक कंक्रीट कंस्ट्रक्शन कर रहे हैं, जो कि पहले शुरुआत में हम लोग शुरू कर रहा था तो चाइना से और कोरिया से हम लोग एल्यूमिनियम शटरिंग इंपोर्ट किया करते थे, मगर अब हमारे यहाँ इतने सारे एल्यूमिनियम फॉर्मवर्क शटरिंग के मैन्युफैक्चरर बन गए हैं और इतनी अच्छी टेक्नोलॉजी से बना रहे हैं वो लोग कि अब हमें बाहर जाने की ज़रूरत नहीं, और यह इंडिया में बन रही है और सस्ती भी है, और उनका जो टाइम है, मैन्युफैक्चरिंग टाइम है, वो भी काफ़ी घट गया है। तो इस वजह से एल्यूमिनियम शटरिंग को अगर हम हिंदुस्तान में ही बना रहे हैं और यहाँ से ही मैन्युफैक्चर करके यहीं यूज़ कर रहे हैं। जो नाउ व्हाई at all aluminum shuttering was required. Aluminum formwork was developed by W.J. Malone, a Canadian engineer, in 1970. Although it came to India after almost 40 years in 2010 or so. Before that, very rare projects were being done with aluminum shuttering. But now, after 10, it is gaining momentum, and now almost 30 to 40% multi-story group housing buildings are being constructed using aluminum shuttering. And इन जो एल्यूमिनियम शटरिंग है उसका जो सबसे बड़ा फायदा है कि वह बहुत ही फास्ट कंस्ट्रक्शन, बहुत ही हाई क्वालिटी कंस्ट्रक्शन और बहुत ही इकोनॉमिकल कंस्ट्रक्शन मेथड है। मैं कोशिश कर रहा हूं कि आज़ादी के महोत्सव के नाम से जो हमने नाम दिया है उसके लिए हिंदी में ज़्यादा से ज़्यादा बोलने की कोशिश करूं, हालांकि बहुत ही टेक्निकल सब्जेक्ट है, मेरे लिए मुश्किल होगा। प्लीज बियर विद मी। इस कंस्ट्रक्शन में हम ऑल वॉल्स, पार्टीशन वॉल, कॉलम, शियर वॉल सब एक साथ कंस्ट्रक्शन करते हैं। लेकिन एल्यूमिनियम शटरिंग क्यों? वाई इंडिजीनियस एल्यूमिनियम शटरिंग? भारत में सबसे बड़ा एल्यूमिनियम उत्पादक है। वी आर द बिगेस्ट एल्यूमिनियम प्रोडक्शन कैपेसिटी, वी हैव द बिगेस्ट बॉक्साइट रिजर्व्स इन इंडिया। सो हमारा जो एल्यूमिनियम है वो सबसे सस्ता भी है और सबसे अच्छा भी है। इवन जो चाइनीज और कोरियन कंपनी हमें पहले एल्यूमिनियम शटरिंग देती थी वो भी इंडिया से ही एल्यूमिनियम इंपोर्ट करते थे। तो क्या करते थे, पहले एल्यूमिनियम इंपोर्ट करते थे, उससे एल्यूमिनियम शटरिंग बनाते थे और शटरिंग हमें भेजते थे। तो इसका मतलब क्या है कि डेफिनेटली उनकी कॉस्ट, ट्रांसपोर्टेशन कॉस्ट भी इसमें इन्वॉल्व थी, मैन्युफैक्चरिंग कॉस्ट भी इन्वॉल्व थी, तो वो ज़्यादा थी। और इंडिया में जब से बनने शुरू हुई है तो इसकी कॉस्ट भी सिग्निफिकेंटली कम हो गई है। दूसरा जो सबसे इम्पॉर्टेंट फैक्टर है, जब हम एल्यूमिनियम शटरिंग से कंस्ट्रक्शन करते हैं तो हमारा जो मटेरियल्स का कंजम्पशन है, मटेरियल्स का मीन्स बिल्डिंग मटेरियल्स का कंजम्पशन, मटेरियल कंजम्पशन इन ओवरऑल बिल्डिंग, दैट रिड्यूसेस टू अराउंड 30%. That's the biggest advantage. I have analyzed that only 0.4 cubic meter per cubic meter of materials are required in a multi-story group housing project. It may be different in the commercial or industrial, but in a group housing project, only 0.4 cubic meter per square meter, sorry, per cubic meter I have written, but per square meter of the floor area, we require the materials. Whereas in conventional infill, when we constructed a framed structure with infill brick walls with plasters, तब हमारा जो मटेरियल्स का कंजम्पशन होता था वो 0.55 से 0.6 क्यूबिक मीटर होता था। तो 0.55 0.6 क्यूबिक मीटर के मुकाबले अभी 0.4 क्यूबिक मीटर हो रहा है पर स्क्वायर मीटर में। और स्टील का कंजम्पशन भी ऑलमोस्ट सेम है, 50 से 60 केजी पर स्क्वायर मीटर ही है, पहले भी और अब भी। इनफैक्ट अगर हम छोटे हाइट की बिल्डिंग बनाए, मीन्स 12 स्टोरी या उससे कम बनाए, तो ये और कम हो जाता है। लेकिन मैंने जो ये लिखा है 50 से 60, क्योंकि आजकल ज़्यादातर बिल्डिंग 15 से 25 स्टोरी के बीच में बन रही है। प्राइवेट सेक्टर में ज़्यादातर बिल्डिंगें बन रही हैं वो 15 से 25 स्टोरी के बीच में बन रही हैं, तो उसमें जो है 50 से 60 kg पर स्क्वायर मीटर का कंजम्पशन होता है। तो इस वजह से होता क्या है कि 0.15 या 0.2 क्यूबिक मीटर पर स्क्वायर मीटर हमारा मटेरियल बचा, उसकी वजह से डेड लोड, बिल्डिंग का डेड लोड वही कम हो जाता है, लगभग 2 टन पर स्क्वायर मीटर, और मतलब 25 फ्लोर में टोटल लोड रिडक्शन। और इसकी वजह से क्या होता है कि टोटल लोड ऑफ द बिल्डिंग कम हो जाता है, तो फाउंडेशन की थिकनेस कम हो जाती है। फाउंडेशन की थिकनेस कम हो जाती है तो हमारा फाउंडेशन का साइज छोटा हो जाता है, उसकी थिकनेस कम हो जाती है, और ओवरऑल फर्दर रिडक्शन हो जाता है। एक और जो मेजर इंपॉर्टेंस है कि हम ड्यूरिंग द कंस्ट्रक्शन कितना एनर्जी, वाटर और मैन पावर लगाते हैं कंस्ट्रक्शन के दौरान। अभी जब हम आरएमसी और स्टील मींस एल्यूमिनियम शटरिंग से जब हम कंस्ट्रक्शन करते हैं तो उसमें दो ही मेजर आइटम होती हैं, एक कंक्रीट और दूसरा स्टील। स्टील का क्योंकि कंजम्पशन ऑलमोस्ट सिमिलर है जो कन्वेंशनल में था, और कंक्रीट का कंस्ट्रक्शन, कंक्रीट का जो कंजम्पशन है एज ए कंक्रीट तो वो उतना ही है, लेकिन ओवरऑल मटेरियल्स काफ़ी कम हो गए। हमने ब्रिक्स यूज ही नहीं की, हमने प्लास्टर के लिए कोर सैंड यूज ही नहीं किया, सैंड यूज ही नहीं किया, हमने फ्लोरिंग और जो वॉल पे वॉल टाइलिंग है उनके लिए भी थिकनेस ऑफ मॉर्टर्स काफ़ी कम हो जाती है, तो उसमें भी सेविंग की। तो उसकी वजह से जो एनर्जी इन्वॉल्व थी ड्यूरिंग द प्रोडक्शन ऑफ दोज मटेरियल्स, ट्रांसपोर्टेशन ऑफ दोज मटेरियल्स, दैट ऑल्सो गेट रिड्यूस्ड। सिमिलरली हमें यहाँ पर वाटर सिर्फ वो कंक्रीट की मिक्सिंग के लिए यूज करना है, और दूसरा उसकी क्यूरिंग के लिए यूज करना है। उसका कंजम्पशन भी कन्वेंशनल शटरिंग, कन्वेंशनल सिस्टम से लगभग 40% कट जाता है। और मैन पावर का जहां तक सवाल है, मैन पावर भी लगभग आधी रह जाती है, रिक्वायरमेंट ऑफ मैन पावर, क्योंकि ब्रिक वर्क के लिए कोई मैन पावर नहीं आपको चाहिए, प्लास्टरिंग के लिए कोई मैन पावर नहीं आपको नहीं चाहिए, इवन जो सरफेस फिनिशेज हैं उनके लिए भी मैन पावर की रिक्वायरमेंट घट जाती है। तो लेकिन थोड़ी सी हायर स्किल सेट के साथ हम 50% मैन पावर के साथ काम कर पाते हैं। तो ये जो 3 महत्वपूर्ण उपलब्धियां इस सिस्टम की, और जिसकी वजह से फास्ट कंस्ट्रक्शन, इकोनॉमिकल कंस्ट्रक्शन, लेस एनर्जी कंजम्पशन, लेस मटेरियल कंजम्पशन, ऑलमोस्ट सिमिलर स्टील कंजम्पशन, ये सब मिला के ये बहुत ही बड़ी उपलब्धि होती है कि एक सिविल इंजीनियर के लिए कि वो 1 या 2 साल में, 1 साल में एक 15 स्टोरी की बिल्डिंग बना के हैंडओवर कर दे, जो कि पहले हम कभी संभव ही नहीं था। हम 4 स्टोरी की बिल्डिंग भी 2 साल में बनाते थे। So I come to the basic points. What is aluminum formwork system? Aluminum formwork system is a construction system for forming cast in situ concrete structure of a building. It is also a system for scheduling, controlling and work of other construction trades such as steel reinforcement, concrete placement and air conditioning, plumbing, electrical conduits. This system is fast, simple, adaptable and very cost effective. It is unique because it forms all the concrete in a building, including wall, floor, slab, column, beam, stair, window, hoods, balconies, various decorative features in exact accordance with the architect requirements. The dimensional accuracy of the concrete work also results in consistent fitting of doors and windows. The smooth of warm finish of the concrete eliminate the need of costly plastering. जो सबसे बड़ा फायदा है एल्यूमिनियम शटरिंग का कि प्लास्टरिंग की रिक्वायरमेंट नहीं होती, ठीक है, और सीपेज अगर आपका पानी फ्लोर पे भर भी गया है तो भी वो अपवर्ड फ्लो नहीं करता और सरफेस को गीला नहीं करता, क्योंकि उसमें कोई पोरोसिटी नहीं है। पोरोसिटी नहीं है तो उसमें कैपिलरी एक्शन नहीं हो पाता है, कैपिलरी एक्शन नहीं होता तो सीपेज की वजह से जो हमारा प्लास्टर और पेंट झड़ता था वो बच जाता है। वो बहुत बड़ी अचीवमेंट है, बहुत बड़ा, इसकी वजह से मेंटेनेंस फ्री बिल्डिंग बना पाते हैं हम लोग। Aluminum formwork system provides aluminum formwork for RCC load bearing, RCC framed multi-story building, and enables walls and slab to be poured in the same operation. This increases efficiency and also produces the extraordinary strong structure with excellent concrete finish. Due to the fine tolerance achieved in the machine metal formwork components, consistent concrete shapes and finishes are obtained floor after floor. क्योंकि ये जो एल्यूमिनियम शटरिंग है वो बिल्कुल स्टैंडर्ड मशीन मेड शटरिंग होती है और उसका सिस्टम भी बिल्कुल स्टैंडर्ड फिक्सिंग का होता है, तो देयर इज नो पॉसिबिलिटी ऑफ टॉलरेंसेस, देयर इज नो पॉसिबिलिटी, और बहुत ही रिजिड सिस्टम होता है। तो इस वजह से एक फ्लोर से ऊपर का फ्लोर जो है अपने आप ऑटोमेटिकली सही हो जाता है, और इस तरह का सिस्टम होता है कि ऑटो फिट, ऑटो करेक्टिव होता है। अगर आपने कहीं पर गलत पैनल लगाया है तो दूसरी जगह पैनल नहीं लग पाएगा, तो जब तक आप उस गलती को ढूंढ नहीं लोगे जब तक आप आगे नहीं बढ़ सकते हो। इस वजह से इसमें गलती होने की कोई संभावना नहीं रहती है। जो डिजाइन आपने आर्किटेक्ट को से जो डिजाइन आया वो अपने फॉर्मवर्क के उसी के बेसिस पे फॉर्मवर्क बनाया और वही रिपीटेटिव होगा। ठीक है। एक और जो सबसे बड़ा अच्छा फायदा इसका क्या है कि इसके पैनल्स का वेट बहुत कम होता है। जो सबसे बड़ा पैनल होता है वॉल पैनल, उसका वेट भी 25 kg होता है, तो एक वर्कर आराम से उसे उठा लेता है। वेरेज कन्वेंशनल शटरिंग में हमारे पैनल्स के वेट बहुत ज़्यादा होते थे और उसके लिए काफ़ी मैन पावर होती थी, इसकी वजह से वो बार बार गिरा देते थे, आड़े तिरछे हो जाते थे वो, और उसकी वजह से फिनिशेस खराब होते थे। So what this advantage of the technology is, aluminum formwork system is highly suited to load bearing wall construction, whereas the traditional formwork consisted of plywood and timber is not suitable for high pressure fresh concrete on the walls. हमें पहले अभी इस वाले सिस्टम में क्या है कि हम 3 मीटर या 6 मीटर तक की वॉल भी एक ही पोर में डाल सकते हैं, वॉल और स्लैब एक साथ डाल सकते हैं। लेकिन अगर पुराने सिस्टम में हम वुडन फॉर्मवर्क करते हैं तो नीचे का जो फॉर्मवर्क है वो फूल जाता था, स्प्रेड हो जाता था, और उसकी वजह से हम उसे डाल नहीं पाते थे और उसे हमें अलग अलग बार में डालना पड़ता, 3 या 4 पोर में जाके एक फ्लोर बन पाता था, जिसकी वजह से उसका टाइम बहुत बढ़ जाता था। सो ऐसा लगता है ऑन द फेस ऑफ इट कि इसकी कॉस्ट बहुत ज़्यादा है, लेकिन सिर्फ इनिशियल इन्वेस्टमेंट थोड़ी सी ज़्यादा है, अदरवाइज इसकी कॉस्ट इफेक्टिवली कम आती है, क्योंकि ओवरऑल जो मटेरियल कंजम्पशन में आपने सेविंग की, जो फिनिशेज में आपने सेविंग की, वो कहीं ज़्यादा है एज कंपेयर टू द cost of the aluminum shuttering itself. और सबसे जो एक और बड़ा फायदा क्या है, जहां पर हाई वैल्यू लैंड है, जैसे दिल्ली के एरिया में आजकल हम बहुत सारा कंस्ट्रक्शन कर रहे हैं, रेनोवेशन, पुरानी हाउसिंग बिल्डिंग्स को बदल के उन्हें मल्टी स्टोरी हाउसिंग में कन्वर्ट कर रहे हैं, तो वहां पर क्या है कि फ्लोर एरिया रेशो ही बहुत महत्वपूर्ण होता है। लगभग 8% एरिया, फ्लोर एरिया बच जाता है, क्योंकि इसमें वॉल्स काफ़ी थिन होती हैं। हम पार्टीशन वॉल नॉर्मली 75 से 80 mm की बनाते हैं, और जो मेन लोड बियरिंग वॉल्स हैं, शेयर वॉल्स हैं, वो 200 mm से 230 mm की बनाते हैं। मीन्स 20 स्टोरी तक के लिए 200 mm सफिशिएंट हो जाता है, और 20 से ऊपर जाने पे 230, और अगर आपको 40 या 50 जाना है तब भी 300 से ज़्यादा कभी नहीं आती। वो 50 स्टोरी पे भी 300 mm थिकनेस वाल की वॉल चल जाती है, और दैट टू ओनली शेयर वॉल्स विच आर गोइंग अप टू द फाउंडेशंस। दूसरा जो सबसे बड़ा फायदा है इसमें, क्योंकि वॉल, स्लैब और सारा पार्टीशन सब एक साथ कंस्ट्रक्ट होता है, तो जैसे मैं अपने पर्सनल एक्सपीरियंस से बता रहा हूँ कि हम लोग 10 दिन में एक फ्लोर बना रहे हैं, और 10 दिन में एक पूरा फ्लोर मीन्स विद ऑल वॉल्स, ऑल इलेक्ट्रिकल फिटिंग्स, ऑल सिस्टम तैयार हो जाता है। उसके बाद उसमें सिर्फ फ्लोर टाइल, वॉल टाइल, थोड़ा सीपी फिटिंग, चाइना वेयर और ये सब काम बचता है, अदरवाइज फ्लैट इज रेडी और फ्लोर इज रेडी। तो इस वजह से जो ओवरऑल टाइम कंजम्पशन है वो बहुत बच जाता है। हमारे जो सरकारी सिस्टम है उसमें हम लोग ज़्यादातर मनी की टाइम वैल्यू को कंसीडर नहीं करते हैं, बहुत कम कंसीडर किया जाता था। अब थोड़ा सा लोगों का ध्यान इस तरफ गया है कि मनी की एक टाइम वैल्यू है जो कि इंटरेस्ट कॉस्ट है। अगर हम एक ही बिल्डिंग जो 1 साल में बनाए वर्सेस 2 साल में बनाए, तो उसमें 1 साल का जो यूटिलाइजेशन वैल्यू वो खत्म कर दी हमने, और 1 साल के इंटरेस्ट कॉस्ट बढ़ा दी। अगर इस वाले फैक्टर को हम सबसे ज्यादा कंसीडर कर लें तो इतना ज्यादा कॉस्ट इफेक्टिव सिस्टम है कि मींस इट इज ऑलमोस्ट सेव 15% ऑन दिस अकाउंट ओनली। दूसरा, ये एनवायरमेंट फ्रेंडली है, क्योंकि इसमें लकड़ी बिल्कुल भी यूज नहीं होती, तो पेड़ कहीं काटना नहीं पड़ता है। ठीक है, सारे के सारे बिल्डिंग मटेरियल ऐसे ही यूज होते हैं जो या तो फैक्ट्री मेड है या तो नेचुरली अवेलेबल है। मीन्स रोड़ी बदरपुर, रोड़ी कोर्स एग्रीगेट्स एंड कोर्स एंड्स, सीमेंट एंड स्टील, दीज आर द मेन रिक्वायरमेंट्स। देन क्योंकि एल्यूमिनियम फॉर्मवर्क का वेट बहुत कम है, तो इसे एक फ्लोर से ऊपर के फ्लोर पे ले जाना बड़ा आसान है। बहुत ही सिंपल असेंबलिंग सिस्टम होता है, तो स्किल लेबर, जो थोड़ी सी स्किल्ड लेबर पुरानी थी, उसे 15 दिन 1 महीने की ट्रेनिंग देने के बाद ही हम जो है उससे काम करवा पाते हैं। बहुत ज़्यादा ट्रेनिंग की ज़रूरत नहीं पड़ती है, लेकिन 1 महीना उसे समझाना पड़ता है कैसे करना है। दूसरा, इसका जो एक बार हमने शटरिंग का सिस्टम सेट बनाया, उसे कितनी बार रिपीट करना है? नॉर्मली 200 रिपीटेशन तक आराम से किए जा सकते हैं, और अगर आपका सिस्टम थोड़ा सा और बेहतर है तो इसे और भी ज़्यादा किया जा सकता है। वो संभव है। लेकिन जैसे ग्रुप हाउसिंग्स हम बना रहे हैं जिसमें सरकार सिमिलर टाइप की हाउसिंग है, सिमिलर टाइप के टावर्स बहुत सारे बनाने हैं, वहां पर तो ये बहुत ही सस्ता पड़ता है। लेकिन अगर मैंने अपने पर्सनल एक्सपीरियंस से बता रहा हूँ कि जहां पर भी हमारे रिपीटेशन 30 से ज्यादा आ जाते हैं, इसका कॉस्ट इफेक्टिव ये और ज्यादा कॉस्ट इफेक्टिव होती चली जाती है। दूसरा क्या है कि इसमें जितना भी आपने शटरिंग मटेरियल यूज किया वो सारा का सारा आइदर तो रीयूज होता है और स्क्रैप में भी उसकी हाई वैल्यू मिल जाती है हमें। इसकी असेंबलिंग बहुत ही सिस्टम में बहुत ही सिंपल है, इसे बहुत ही आसानी से असेंबल किया जा सकता है। थोड़े से अनस्किल्ड लेबर को थोड़ी सी ट्रेनिंग देके हम करवा पाते हैं काम। पिन एंड वैज सिस्टम होता है जिसमें ऑटोमेटिकली पिन ठोकने से वो ऑटोमेटिकली टाइट हो जाता है, जिसकी वजह से, और अगर उसने टाइट नहीं किया तो दूसरा पैनल नहीं लगेगा। तो इस तरह का सिस्टम है कि सेल्फ करेक्टिव है वो, और बहुत ही इस तरह। दूसरा एक बहुत बढ़िया इसमें क्या है कि इसमें प्रोब को वहीं छोड़ के हम बाकी की सारी शटरिंग रिमूव कर सकते हैं। इससे क्या फायदा होता है कि प्रोब वहीं रहता है और अगला फ्लोर उसके अगला फ्लोर हम कास्ट कर पाते हैं, क्योंकि कंक्रीट हो सकता है 8 दिन बाद या 6 दिन बाद हम प्रोब जब मटेरियल रिमूव कर रहे हैं, शटरिंग मटेरियल 4 दिन बाद रिमूव कर रहे हैं तो उसने स्ट्रेंथ नहीं ली होगी। लेकिन प्रॉप्स को अगर हम वहीं छोड़ देते हैं तो इतनी स्ट्रेंथ उसमें होती है, और वो प्रॉप फिर हम तीसरे सेट के बाद 2 एडिशनल सेट ऑफ प्रॉप्स रखते हैं, जिसकी वजह से 2 अगले फ्लोर बन जाते हैं। तब नीचे वाला निकाल के ऊपर लेके जाते हैं। तो इससे बहुत ही फायदा क्या होता है कि बहुत ही फास्ट फॉरवर्ड ये हो जाता है। तो इसकी स्पीड बहुत अच्छी है, क्वालिटी बहुत, जो फाइनल फिनिश क्वालिटी आती है। अच्छा, अभी क्या है कि कंक्रीट टेक्नोलॉजी में बहुत एडवांसमेंट हो गया है। ऑलमोस्ट एवरी पर्सन यूजेस द डिजाइन मिक्स कंक्रीट इन द एंड हैविंग द कंक्रीट प्लांट एट द साइट और एट द फैक्ट्री टाइप ऑफ सेटअप है। वहां पर कंक्रीट का क्वालिटी कंट्रोल बहुत ही अच्छा होता है, और उसकी वजह से M30 से M40 या M40 से M50 बनाने में जो कॉस्ट का वेरिएशन है वो बहुत कम होता है। ऐसा नहीं है कि M30 से M50 जाने में डबल हो जाती है कॉस्ट, इट हार्डली इंक्रीजेस बाय 300-400 रुपीज। तो हम लोग अपने सेक्टर में जो यूज कर रहे हैं, नॉर्मली हम M40 और M50 कंक्रीट यूज करते हैं, जो कि हमारे यहाँ क्वालिटी कंट्रोल लैब से आराम से बन के आती है, और फ्लाई ऐश यूज करने से इसकी ओवरऑल कॉस्ट काफी घट जाती है और फिनिशेस बहुत बढ़िया हो जाती हैं, बहुत ही। और ये बिल्कुल इम्परवियस सेल्फ कॉम्पैक्टिंग कंक्रीट बनती है, और इसका जो सबसे बड़ा फायदा क्या होता है कि मेंटेनेबिलिटी बड़ी आसान हो जाती है बाद में। दूसरा, जब हम एक बार हमने फ्लोर एक बार कंक्रीट पोर कर दी और शटरिंग हटा दी, तो उसके बाद प्लास्टर नहीं करना है, हमें ब्रिक वर्क नहीं करना है, तो दोबारा से पूरी बिल्डिंग को वो नहीं करना है, तो वाटर रिक्वायरमेंट बहुत घट जाती है। ठीक है, इसमें डोर और विंडो क्योंकि स्टैंडर्ड साइज के हैं, हर फ्लोर पे सेम साइज के लगेंगे, बिल्कुल एग्जैक्ट सेम, तो ऐसा नहीं होता कि वेरिएशन होगा उनके साइज में। आप पुराने टाइप की बिल्डिंग में देखेंगे, आपने 2 इंच इधर बड़ा कर दिया, 3 इंच उधर छोटा कर दिया एंड सो ऑन, ऐसी गड़बड़ियां होती थी, जो इसमें बहुत ही आसानी से अचीव कर ली जाती हैं एक्यूरेसी। इसमें टॉलरेंस बहुत ही कम होती है, मतलब मीन्स ना तो प्लास्टर के लिए कोई टॉलरेंस ही है, ना डोर विंडोज की कोई टॉलरेंस ही है। ठीक है, जो इंटरनल फिनिशेस है वो हम 2 से 3 mm का लेवल प्लास्ट और पट्टी लगा के अचीव कर लेते हैं, और जो एक्सटर्नल है वो लेवल प्लास्ट और पट्टी लगा के डायरेक्ट फिनिश कर देते हैं। तो ये बहुत ही आसान है। जो ओवरऑल थिकनेस है वो कंक्रीट की थिकनेस से 5 mm से ज्यादा नहीं बढ़ती है कभी भी।
थोड़ा फास्ट कीजिए, आपका टाइम इज ओवर।
ओके, in this if we want to understand the construction methodology, we achieve this in 10 days. In day 1 we do the day 1 and 2 we do the level wall reinforcement, day 3 and 4 formwork, day 5 beam and slab reinforcement, 5 and 6, 7 electrical and overall checking, 8 pouring, then 9 layout and de-shuttering, 10 de-shuttering of slab, beam panel and upper level reinforcement, and so on. This way we achieve the cycle of 10 days. It can be achieved in 8 days at places. We have achieved that also, but that is the standard I am following. So what is the necessity? क्योंकि आज की डेट में हाउसिंग पे एक बहुत बड़ा ट्रस्ट है सरकार का, और हमें चाहिए कि बहुत ज्यादा मास हाउसिंग हम करें और क्वालिटी हाउसिंग करें जिसकी लाइफ बहुत ज्यादा हो। ऐसा ना हो कि 3-15 साल बाद फिर से हमें बदलना पड़े उस हाउस को। लो क्वालिटी हाउसिंग नहीं चाहिए, तो हमें ये मेथड पे जाना ही पड़ेगा। दूसरा, हमारी लैंड रिक्वायरमेंट बहुत घट जाती है बिकॉज इट इज सुटेबल फॉर मल्टी स्टोरी हाउसिंग ओनली। तो लैंड रिक्वायरमेंट, बढ़ती हुई पॉपुलेशन में हमें लैंड रिक्वायरमेंट, हमारे पास लैंड अवेलेबिलिटी बहुत कम है, तो इसका उसके लिए भी बहुत ही अच्छा सिस्टम है ये। देन इसमें स्पीड में क्वालिटी आएगी, क्वालिटी कंस्ट्रक्शन आएगा, कंट्रोल्ड रहेगा सब कुछ, वो बहुत अच्छा है। ठीक है, तो इंडियन कंडीशन में मास हाउसिंग के लिए सबसे सुटेबल सिस्टम है। What is the advantage? No plastering required, saving on overhead expenses and speedy construction, monolithic, crack-free structure, does not require timber or plywood, casting of wall slab, always simultaneously, hence total system forms a complete concrete structure, floor slab, forms removed without moving props, earthquake resistant of resulting structure is increases very high. The former is specifically designed for rapid construction on all types of architectural layout and custom design to suit project requirement. The system becomes cost effective where there is considerable repetition of floor layouts. After the 50 cycle of reuse of this formwork, we will reach the break-even point and to the conventional checking. The unsurpassed construction speed with high quality finish, eliminate plastering, system becomes cost effective, panel can be reused 200 times, erected using semi-skilled, skilled labor, require no crane or heavy lifting equipment, suitable for low as well as high-rise building, no need to use any timber or plywood, resulting structure highly durable and very cost effective. So if we compare this, although I had already explained the conventional formwork and in situ में क्या फर्क है, ठीक है, स्पीड के बारे में मैंने पहले ही बात कर लिया। एस्थेटिकली ये बहुत अच्छे साफ, क्योंकि स्ट्रक्चर जो है क्रैक फ्री होता है, सीपेज नहीं आती, तो एस्थेटिक स्टेज की बहुत अच्छी रहती हैं। एक्सटर्नल फिनिशेस बहुत कम करनी पड़ती है क्योंकि आजकल जो पेंट आ रहे हैं वो 10 ईयर वारंटी वाले आ रहे हैं। अभी हमारा जो स्टैंडर्ड है 4 ईयर में एक्सटर्नल प्लांट पेंटिंग करेंगे, दोबारा 2 साल में इंटरनल पेंटिंग करेंगे, इसमें इस साइकिल को बढ़ा के 5 साल और 10 साल किया जा सकता है आसानी से। तो जो मेंटेनेंस कॉस्ट है वो बहुत कम घट जाती है। Even our maintenance cost is just 0.5% of the initial cost per year only. Consumption of cement almost normal रहता है, consumption of steel भी सेम ही रहता है, कोई ज्यादा फर्क नहीं पड़ता है। ठीक है, मेंटेनेंस रिक्वायरमेंट के बारे में बात की, क्योंकि सीपेज इसमें हो नहीं पाता है, इसलिए मेंटेनेंस रिक्वायरमेंट बहुत ही घट जाती है। तो इन सब चीजों को समराइज करते हुए मैं यह बताना चाहता हूं कि हमारे जो आने वाले प्रोजेक्ट्स हैं जिसमें हाउसिंग की रिक्वायरमेंट बहुत ज़्यादा है और मास हाउसिंग हमें करना चाहिए, उसमें इस तरह के सिस्टम को इंडिजीनियस एल्यूमिनियम शटरिंग से अगर हम यूज़ करें तो बहुत ही देश के लिए हेल्पफुल होगा। थैंक यू। एनी क्वेश्चन प्लीज?
Thank you, sir, for your enlightening presentation. We have CPWD also has moved towards this new technology, and we are using it in our projects. Yes, now we are moving to our next presentation, and next presentation is on flyover, new technologies in Indian context, and our speaker is Dinesh Kumar ji, former CPWD. So I request Dinesh Kumar ji to take over the presentation.
Okay, good afternoon to everybody.
Good afternoon, sir.
मेरी आवाज आ रही है?
Yes, sir. Yes, sir.
Yes, sir.
Good afternoon, namaskar. As already introduced, I am a part and parcel of CPWD only. I had been 37.5 years in CPWD and PWD, but mostly remain in PWD. First of all, because most of the gathering is from CPWD, I want to share the views after my retirement after 6 years, that outside the CPWD, we are same, and we are having good reputation in outside the CPWD. We should not hesitate that we are in CPWD or in PWD. We are having a very good reputation after even in the market or even otherwise in construction industry. As far as building is concerned, people consider CPWD is pioneer, and all especially and all our code of practices being adopted. But for highway and roads and bridges, we are not also far behind. I can say with definitely that most of the new items, most of the indigenous structures are being done by PWD only. As far as some my colleagues will be from PWD, they may be knowing that micro surfacing, mastic, and micro surfacing, mastic, and some other mixes in flexible pavement has been first used by PWD only. Being CRI in Delhi, so in a road sector also we are not far behind, and all specification is adopted as per PWD practice only. And with this, I start my presentation. Basically, it is on new technology on flyover and bridges, or we can say on elevated roads. And this is based on my practical experience in the field. And I think it should all the people should understand this. This is very simple. In simple way, I'm just going to present. Thank you. And our next traditional bridges. Normally, earlier traditional bridges were made to cross the rivers, and the wooden and floating structures were made in the ancient period, and even masonry arch bridges were used, and well foundation was only a solution for big rivers and big nalas, and open solid foundation for small culvert, small bridges. But now we use pile foundation are preferred. Even in Ganga bridge, even in Patna, we are using the pile foundation. Earlier, everywhere you might have seen only well foundation was there, or एक well foundation को बनाने में 6 महीने लगते हैं और फिर उसको बरसात के लिए छोड़ दिया जाता था. That was a very time consuming process. Now pile foundation, because technology is available, it is preferred. Then this is the story of the superstructure. Thin and higher structure. Earlier it was higher structure were used. Single pillar bridges or flyovers are now being constructed, and I can say with this that Delhi PWD are part of CPWD. We are the pioneer for single pillar flyover bridges. Spinal beam structures we have constructed. Pile foundation instead of well foundation, and then extra dose bridges instead of suspension cantilever bridges. You might have heard the suspension cantilever bridge. The example is Patna Gai Ghat bridge was a suspension cantilever bridge, but now the new bridge in Patna is a extra dose bridge only. These are the our traditional bridge or flyovers. What I am going to cover that when we make a elevated road or flyover, this at ground we were occupying around 20 meter, and top we are giving 24 meter. Then same space was used in the ground and same almost on elevated. These are some pictures, either 4 pillars. This is I think from Ashram flyover, existing one. This is again Africa Avenue IIT flyover. Of course, it is a steel structure. These are just to show you. This is also Moti Bagh flyover. And this is our new structure, single pillar. We can say this because our politician also and our requirement was also, they were telling हमें 2 मंजिल road चाहिए. 2 मंजिल road, one in ground level and the one on top level. Earlier we made the Narana elevated road 2.5 kilometer, but due to lack of technology or lack of awards, we can say that we on ground we have occupied 20 meters and on top we created 24 meters. But in these new elevated roads, we have occupied only 3 meters in the center one at bottom, and we have created 24 meters on top. This is the another view of this elevated road, and this is the new technology which I will be covering in bridge and flyover. This is thin and lighter structure, single pillar bridges and flyover, a spinal beam structure, pile foundation instead of well foundation, as I already told, and the extra dose bridges is latest Extra gauge bridge is nothing but a mix of suspension bridges and cantilever bridges. This is a suspension cantilever bridge, one view. This is another view of suspension cantilever bridge. And this is our, we can say, spinal beam bridge, either single pillar flyovers or whatever you say. This is elevated road newly constructed in Rohini, Delhi, outer ring road. And this is a Mulchan flyover. Then this is extra gauge bridge, where it is a mixing of the two. And this new technology, I will want to share the my views on this technology, which we have made a new corridors in Vikaspuri to Mukarba Chowk, outer ring road, and in total in Delhi we have constructed around 14-kilometer road, where earlier now this is the technology is very simple. Normally the flyover or bridges, the load was transferred from load is transferred from pier to pier or from abutment to abutment, and it was mostly one-way slab. It is generally only one-way slab, and the thickness from one end to another end remains same, constant. If we make a 40-meter span, then the normal our bottom depth of the beam was 2.8 meter. And in this, we can say spinal beam or two-way mechanism of load transfer, where the main load is transferred to one single pillar, and this is one longitudinal. This is one longitudinal spinal beam, and the load is transferred from one edge to the center this way, and you will see the edge, this wedge, this much structure is reduced. This much structure is reduced, and by this reduction of this structure, the weight of the bridge is also reduced by 25%. And by reduction of this weight itself, the concrete is reduced, our piers is reduced, our foundation is reduced, and in overall we save around 25% of the concrete, and overall 15% of the saving. This is the theory that this is one pillar, and this is another pillar, and this is one spinal beam is erected in center. One spinal beam is erected in center, and this you can see, this is the first part of the spinal beam. Of course, all beams and everything is segmental only, and this is a cantilever portion. This is known as flange. This is erected first. This you can see, but the erection system is to be followed. First we erect one wing, then to keep the balance, the another wing is to be erected. Then another flange is to be, wing is to be erected, so that the balance is maintained. And this is the final view. And this, the whole span work as one unit. The whole span is one unit, and the concrete here is reduced. You will see that concrete is reduced in this section, and this much is reduced in its weight, and the overall weight means reduction in the saving. This is the one sketch, the final sketch. How we, again I will say that the concrete which was earlier here also now is curtailed down. This is the view of this cantilever wing segment. You can see here. These are the wing segment, and here the thickness of this portion is only 20 centimeter, and here the thickness of this beam is 2.8 meter over the center, because the load is transferred in that way. These are the construction stages. You can see this is the actual figure I have taken from Vikaspuri to Mirabag, which is constructed between 2013 and 2016. This is the construction yard at Vikaspuri. These are the spinal segments in casting yard. The height of a segment is around 2.8. This height is around 2.8 kilometer, and our span was 36 meter. These are one wing segment, and this length is around 9 meter, and this height is 2.8 again. And these are the pile. This is of course normal pile, but the dia of the pile is in the casting yard, the case of central segment, spinal segment, we can say. This is a pier. This is a pier reinforcement, and this is final casting of a pier. This is a pile cap work in, and this is again casting of a pier. Again, final shape of a pier for adjusting the final shape. This is the erection, and erection is a very typical, and we have to be very careful for erection. If we don't follow any methodology, it may create a problem. There was some accident also in Bombay, where this spinal beam were constructed. Work was being done by L&T, and due to hurry, they done some mistake in consequence of the methodology, and due to this not following the methodology, that may create a problem. There's some accident also took place there. The main theory is that whenever you fix these wings, the counter wings should also be fixed before moving further to the launching ladder. This is erection of central spine, which is one of the typical. Again, view of this is a spinal beam. This is a spinal beam, and after erection, you have to stretch this. The stretching is done first, so that the one spinal beam is completed before erection of the wings. Then wings are started, and it is from one side to another side. The whole span cannot be done. Normally, it is as per the design methodology only. Normally, 2 wings on one side and 2 wings on other side. This is the theory normally we followed. This is that way. This is the carrying of a wing, because the width of the wing itself is 9 meter. This is erection of a wing. This is again erection system. You can see that we have erected this side and this side first before completing the whole span. This is a theory, and this is the complete stressing has been done. All segment has been stretched, and then cross stitching, we can say cross stressing is done, and this is the final shape. And this, you can say, this is the these are known as stitches when 2 wings are a bit connected each other, but a gap is left around it, so that it is done cast in G2, so to keep the top surface even. Otherwise, it may create a problem. This is the bottom view of stitching. This is one. This is one. This is one wing. One wing is like this, and this is another wing, and this is a gap around 2 to 3 feet In our case, it was, I think, 75 centimeter. And it is done only cast in situ. So that the match fixing is done. This is the, again, lateral stitch between wing segments. This is the final stressing. This is again longitudinal stressing. This is another view of a stressing. This is the final, ultimately this is our spinal beam which has been erected before before erection of the flanks, before erecting the wings. And now the wings. Erection of fascia panel. This is also a typical exercise. We should erect this and then another side simultaneously to keep the balance. Erection of fascia panel of crash barrier. Casting of side crash barrier and center mark, because it is done at in situ. This is wing wall. This is the final shape over that. And this is the final shape of the bottom view. Again, a bottom view. You see that we have occupied only 3.5 meter in the bottom, and this top width is 24 meter. Ultimate top carriageway is 24 meter. Almost the same. Almost the 6-lane traffic is above, and the same 6-lane traffic is below. So this way we have added the extra carriageway. So earlier it was not this. This is final view. Earlier it was the phase. On ground we were just occupying like this. Yeah, just this is another, some other photograph of Delhi. But before going further, I want to just say that the decision is to be taken by us only. Nobody will suggest anything except the departmental persons. We have to be very authoritative also, and very careful also while selecting the technology. While implementing this technology, we have followed foolproof method. I put one consultant for designing, one for proof checking, one we have taken third opinion from the IIT, and then fourth as an expert also before going to this implemented. Because everybody when see they used to say कि काफी मजबूत है, क्या ये ट्रैफिक ले सकता है? Then because it is the first time in India. In Delhi, this was the first elevated road on single pillar. These are just another flyovers of Delhi. Just I have caught for a glimpse of the viewers and the persons available from CPWD, because everybody may not be aware, but in PWD we are doing wonders in infrastructures, particularly in flyovers. That's why Delhi is called now a city of flyovers also. These are just flyover at Epsa border, grey separator. These are just another views of the structure which Delhi PWD is part of CPWD and has done. Gazipur crossing, NH24, grade separator Anand Vihar, subway at Vikas Marg, and this is the new FOB. Again, FOB. This is one FOB at Gazipur. We can say this is a suspended bridge. Thank you.
Thank you, sir, for your very well presentation. I think with fast-moving urbanization and massive circle road development, these technologies will very useful. And now we are moving to our last presentation, and this presentation will be held by Dr. Ken Soni, former EDG CPWD, and Srimati Usha Batra, former SDG CPWD. And the topic of the presentation is bamboo, the building material of our future. So I request Dr. K.M. Soni sir and Srimati Usha Batra ma'am to take over this platform and start the presentation.
Thank you, sir. Am I audible?
Yes, ma'am.
Okay. First of all, I would like to convey my thanks to CPWD for giving me an opportunity to connect myself with it again after superannuation 1.5 years back. So आजकल हम न्यूज़ में डेली ही सुन रहे हैं, almost every second or third day we have the news that reducing greenhouse gas is the top priority. National Solar Mission was launched on 11, which had set a target of 20 gigawatts of solar power by year 2022. Cabinet in its meeting held on 17th June 2015 had approved a revision of the target from 20 gigawatts to 100 gigawatts. The speed, just see. India is the world's third largest consumer of electricity and world's third largest renewable energy producer, with 38% of total installed energy capacity in 2020 from renewable sources. India has also set a target of producing 175 gigawatts by 22 and now 450 gigawatts by 2030 from renewable energy. Now, the latest news is that India might agree to the net zero emission sometime after 2050. Now, for achieving all these achievements, we need to strictly implement energy efficiency measures and design of green buildings, along with converting existing buildings to green buildings, which necessitates use of green building materials. Bamboo is one such material which can be used in buildings for structural as well as non-structural members due to its vast advantages. Dr. Soni will take you all through the journey of this amazing material, bamboo. I would now request Dr. K.M. Soni to start the presentation. Thank you.
Good afternoon, everybody. Request to the administrator to please upload the PPT. Satendra, will you please upload
Sir. Yes, sir. This is uploading, sir. Please wait for.
Is it visible now?
Yes, sir. Yes, sir.
Okay. Good afternoon once again, everybody. I'm K.M. Soni, retired from CPWD. Today, I'll be talking on different material. We know there are a large number of new materials and also available indigenously. But bamboo is one of the material which is quite available in country. Not only in country, but all over the world it is available. We'll discuss whether we can make use of it, particularly in construction. So far, we have not been using this material in construction because this was not being treated as the construction material. And we know that bamboo bamboo is one of the material which grows very fast. In fact, uh, between 3 to 5 or 4 to 6 years, it can be harvested. And this, as I have discussed, that this grows in many parts of India, but particularly in northeastern part of the country and also in Maharashtra and so. And I'll tell you that Maharashtra PWD has already come out in their schedule of rates that they have included this bamboo as a construction material. So this is a good thing that we have started thinking about bamboo being used in construction, particularly in structural material, as a structural material. And as Madam Batra has told, this is renewable and a green material. One is it is reported that it has high compressive strength even, and this is reported that this is quite comparable with almost as mild steel, and can be used in many applications. We know that we have been traditionally using this material for non-structural members, but structural members we have not been using earlier, and then in aesthetic also we are using it. Uh, and then, as I told that if we have any material, any new material, in fact, then there are few requirements. One is that it should be aesthetic. Second is functional. Functional is very important. Third, durability. So we'll talk about the durability. We know that RCC structures are quite durable. That's why RCC has gained so much importance. And then we all civil engineers know that RCC has one drawback, and that is corrosion. And because of the corrosion, we face the problem of the durability. So if we are able to substitute this steel with some other material, then probably this can be more durable because it will not be corroded. So these things we will be discussing. ये फुल स्क्रीन दिख रहा है आपको या छोटा दिख रहा है?
फुल है सर, फुल है.
Okay. Now, if you see this photo over bridge at Guwahati, I have taken this from one of the site, but this is not used basically as a structural material. This is for decoration. So what has been done is this material, this bridge has been decorated. So it is being used as a decorative material also. It's good nevertheless, because we are thinking that its use is increasing. And this really looks nice, though I'm not recommending that it should be used in open bamboo, but still. Now, what are the drawbacks? Everybody may be thinking that the bamboo can be used. Bamboo, we know this is quite fragile, and we know that this succumb to cracking and splitting, particularly along its core. And we know that जो उसकी गांठें होती हैं उसको नोड बोलते हैं. And then it is not open from inside between the nodes. So that has a small. We will have to see how it is done. Then second is that we know that this material is fragile or is liable for the insects. So why it is? Because this has starch. मीठा सबको अच्छा लगता है, तो जो इंसेक्ट्स को भी अच्छा लगता है. सो if this starch is removed, then it becomes durable. So main is that bamboo cannot be used directly from the crop, and it has to be treated properly. Once it is treated, starch is gone from the bamboo, then it is durable. So second is that all the bamboos cannot be used. So, and then the size means, when I'm saying size, it means diameter of the bamboo and length of the bamboo. These two are very important. And so it is to be selected properly. It is to be selected, and if the bamboos are of a smaller dia, they are to be sorted. And then drying and shaping can be done. And another advantage of the bamboo is that we can shape in any shape. Suppose it is to be curved, then we can just warm it or heat it, and then put between the jig, and it can be shaped. So that is added advantage. And then, as I told, that treatment is very important in case of bamboo. And normally, you will see in the literature that it is done with borax and boric acid. So, a solution of borax and boric acid is taken, and then bamboo is dipped into this, or there are some other methods. So, by that way, it is treated because nowadays natural treatment is hardly done. So advantage of the bamboo as a building material becomes this is lightweight, cost effective, non-toxic as a green material, and it has high tensile strength as I have told, almost as steel, particularly mild steel, and a higher capability of bamboo to resist fire and is non-corrosive, so it becomes durable. And then let us see how durable it is. It is said that for about 50 years it has the easily the service life of 50 years. But there are some structures where this is even existing beyond 200 years. So we will not say that 200 years, but treated bamboo can have a service life of about 50 years or more. And then I have told that not all bamboos, because it is to be treated. So we must remember that only when we take out the starch and then we treat it, then only the bamboo is durable. So that has to be understood. And then there are precautions for use of bamboo. We should avoid direct contact with soil, because soil may have some certain chemicals and it has effect on the bamboo. So we should avoid, and if it is to be used along with the soil, then it should be coated. Generally, economical coating is through bitumen, so it is to be coated. And then avoid use underground without protection, that I have already told. And do not use nails. What happens in timbers, we normally use nails and screws. So in bamboo, you will see that this should be avoided. Nailing or nailing should be avoided. So what is to be done? If nailing is not to be done, what can be done? So either we should have hooks or we should have bolts. So these two types of the treatments are done for the bamboo, and then it doesn't get split. So we will have to drill the holes in the bamboo, and do not drop bamboos from a height or use hammer. So these are some of the precautions which are to be taken. You see here this bamboo, two photos are there. Left side hooks have been used, and right side bolting has been done. And this bolting was done in one of the structure in India Pavilion at Shanghai. So not difficult, it can be bolted. Bamboo is to be selected. So there are some species there are a large number of species of bamboo around the world, but only selected species can be used in construction. And then it is said some literature says that 3 to 5 years, but mostly if we have 4 to 6 years maturity period, then matured bamboo can be taken and it can be treated. Normally, the diameter at the root side, this is not cut from the root. Some length is left, and then this should be this should have diameter of not less than 100 mm. That is 4 inch से कम नहीं होना चाहिए. And we get the length of about 4 to 6 meters. Even when we used bamboo in Shanghai, it was about 6 meter length. And then remember that there are some species only which are suitable for the construction. Now, coming to preservation first, as we have told that treatment is required and essential. As I told that there is a solution or mixture of boric and borax, boric acid and borax, that is generally taken in 1:1.5 ratio. And then this has advantage because it is not toxic. That much toxicity is not there, but there are large number of other chemicals also, and they are said to be toxic. That's why normally we don't use. But wherever the toxicity is not the problem and it is inside, it can be used. But otherwise, it is general practice. This boric acid and borax solution is used for the treatment of the bamboos. Another method is just boil bamboos to remove the starch. That can also be done. That was a natural process earlier being done, but in large scale now it is not done, and it is industrially it is done through boric acid and borax solution. There are small things you can see on the right side that what they do. You see, one important thing I forgot to tell you that bamboo is to be treated from inside also. That is important. Now we know that nodes are there, so and they are blocked naturally. So that solution will not go inside bamboo. So if you are treating from outside, this will not be effective. So what is to be done is that we are to take action that the treatment is done from inside. So that solution, whatever we are using, suppose boric acid and borax, that should go inside the bamboo. So how it is done? Then we are to take out the, we are to pre-drill the hole. So one method is that we pre-drill the hole all along the bamboo length, and then we put up in the tank. And second is that manually, if we are doing, then we still we will have to do the drills, and then solution is to be filled up. You can see in the third picture that is shown. But commercially, it is done same as I have told. In India Pavilion Shanghai, when we used that bamboo, so what we did, that was a little different from this all along piercing of the bamboo from inside. But we did between two nodes, we did two drills, two holes, and on opposite side. So suppose when we put up this bamboo in the tank, so this solution will go from one hole, and from another hole it will come out. So entire length between the nodes, this bamboo get treated. So this is how treatment is done. So it is important that treatment is done from inside. Otherwise, it will not be durable. So I found out one of the sites. This was interesting. For construction, you can see on the left, they are just sorting the bamboo, matured bamboo. Then, as I've told that this is thicker at the bottom and thinner at the ends. So that they are doing, they are just taking it, and then you can see they are drilling along the length of the bamboo total, and then they are just putting here longitudinally in the store, and then they are putting in the tank for treatment. Once it is treated, they are taking out and इसको खड़ा कर देते हैं इस तरह से vertically, so that this solution will go out, and this is to be rotated because air drying should be done on all the sides. So this is rotated normally, and then after rotating, then this is put stacked and ready for use in the structural members. So this is quite interesting. So as I told that after drying, bamboo can be used, and sometime in that some of you maybe might have already seen the treatment of bamboo where air drying was done, but it is not done nowadays. Now it is on commercially it is done. Now processing we have already discussed. It is to be sorted, dried, saved, and treated. And again I am saying that please do not use untreated bamboo, and treatment should be done from outside as well as from inside. Inside is more important than outside. So that is to be ensured. Now there are large number of bamboo species available, but for construction they are limited. And as I told that we in India Pavilion Shanghai we used Mosu bamboo, so that was used by us. But in America and Central Asia or Latin America, there is like Guadua or Chokisa is used. And but in Maharashtra schedule of rate, I was telling in Nagpur, they are using bambusa bamboo, and that is available in their schedule of rates now. Now I searched the literature and where the research is going on. This is just a research stage, I will say. But then bamboo is being used in footings, that is being used in walls, columns, beams, and slabs. The persons who have worked in Northeast, particularly in Assam or northeastern part of the country earlier, they know that we are using bamboo, woven bamboo strips, and then we are doing the plaster from both the sides in walling. But you know that nowadays monolithic construction, in monolithic construction we are using steel for the walls. Probably, maybe in future that we are replacing this steel with bamboos, solid bamboos. Solid means total bamboos without splitting. That is also possible. So traditionally we are using, that is not big thing, but for non-structural or members. And then nowadays a lot of research is going in all the fields. You can see that people are now researching for use in columns. They are researching for use in beams, and they are doing research for use in the slabs. And one thing that I will say that still some of the people, some of the researchers, they are trying that bamboo should be used as reinforcement in RCC construction. But I don't know whether we should go for use of bamboo as a composite construction. It means all the bamboo will be there, and then composite will be only from outside, it will be concreting. So it is durable and it is not directly exposed to the weather conditions. So that is also to be found out. But you will see that people are now using. You will see in the northeastern part or some you see they were using in post, they were using in beams and all that. So and they are quite durable structures. Now I'll take some time for to tell you that how this was used in Shanghai. Now we were told to construct India Pavilion in when I was working in Ministry of Commerce, that is ITPO, Maidan. So then we thought that our consultant told that we'll be using bamboo in construction, and we'll tell to the world that we can use bamboo in structural members. So this India Pavilion had basically three parts. One was the vault, which you are seeing from the front, and back you are seeing the dome. But main was the dome. If you search this bamboo dome in India Pavilion, you will get large number of pictures and literature in the website. And this dome was 34 meter of dia. So 34 meter dia is a large dia. So and here bamboo was used. So this became the news of the world in that time. So this I'll be discussing, and you'll see that this bamboo in vault is simple. This has been shaped as per the requirement, and then bamboo was used on. You can see this is beam, steel beam. What steel beam it has been used. Now connections are very important. How to make the connection of bamboo with RCC, that means with concrete, or with steel, or even the bamboo to bamboo. Bamboo to bamboo, because bamboo has length only of about 6 meters we have discussed. But suppose 34 meter dia bamboo is dome is to be constructed, or suppose 12 meter or 15 meter or 20 meter is to be done, then how it is to be done? So that connecting the bamboos together is also a science or an art. You see this bamboo dome, I have told that this had the diameter of 34 meter diameter. It was told that this is the largest bamboo dome of the world. So how it was done? Now you see here that one thing that you can see, because it is the dome, so some of the bamboos were up to certain distance, and then there some of the bamboos were going on up to the end on the top. Now if two bamboos are to be connected, then what we did, we inserted one of the reinforcement, one of the steel bar in one of the bamboo from one end, and then from another end of the reinforcement was inserted in another bamboo. And because we drilled the hole in both the bamboos between the nodes, from there we micro concrete was inserted on both the sides. So basically, it was RCC sort of connection between two bamboos. So it has adequate strength. It means that between two bamboos without overlapping, the connection was through RCC. So that was done there. And if you see on the left bottom, then when we first tried that we will have with steel beam or RCC beam. Suppose I am discussing RCC beam. In RCC, we had again that steel reinforcement coming out. With that, suppose the length is this, suppose 2 feet is required, then 260 centimeter bar was protruding, and then that bar was going inside the bamboo, and in the bamboo we had pre-drilled hole as I have told, and from there the concrete, micro concrete or rich cement mortar was being inserted, so that it becomes one good connection there or of the adequate strength. So this we did, and you see there are 6 bamboos here. So 1 was at the bottom, 2 at further, and 3 further. So this was mock-up. Then so it means 6 bamboos were interconnected through bolting. So that behaved as a one beam, that one part for a beam. So 6 bamboos were interconnected. 2, this is shown just how the bolting is to be done. And third, you will see that after we did mock-up, as you are seeing here in the left one, right side when we tried, and we thought that this bamboo, when we are putting in steel beam or RCC member, then maybe that it gets splitted later in the future, or may have some cracks. So what we did, we then researched and we took such type of caps. You can see. So this is steel member just like that. So इसको universe उल्टा कर दीजिए. So this will come. इसका जो this will be upside. You will see that this will house. So bamboo was put inside the reinforcement that was housing in this one socket type thing. And then we did micro concrete inside. So there was no chance of splitting the bamboo. So this is how the connections were done. You see here in steel, even a steel beam reinforcement could be welded, and then again in bamboo again here this is again we can have that housed stainless steel socket, and over that in that one bamboo can go inside. So then again, as I am told on the right side, you can see the steel is coming out, and then bamboo first that socket or steel plate will go inside, and then over that this bamboo will come, and then micro concrete or rich cement mortar will come inside. So this is how it was done. And then we didn't have much of the literature, particularly the codes and specifications. So what we did, we had this mock-up done, and you know that it had all the loads, 34-meter dia bamboo dome. We had all the beams of the bamboo, and then both sides on longitudinal and lateral side, all bamboo. Then over that we had RCC slab, and then over that RCC means ferro cement slab was there. Then over that we had waterproofing treatment, and over waterproofing treatment again we had more than 200 lakhs of the live plants. So that much load was coming. So load was as good as or even more than the load normally we consider for the RCC members. So this is what I am saying, how the construction was done. You see that this bamboo is going up. This is because of the shape. This is going up. Any shape it can be done. We did, as I told, that we did shaping. over that you can see that RCC being done, and over this then we had waterproofing. So for waterproofing also we did a special arrangement, because over this we were not able to do, so we did PVC board, and then waterproofing first with geotextile, then PVC board, then we did over that PVC board all plants, more than 2 lakhs plants over that, and then our workers were going for the maintenance. So this was full load, and this is final set. You can see this copper tree of life of Buddha was done with copper, and then we had some small windmill and all those things that to show that this is green, and these are the green plants. You will see the large number of green plants, so more than 200 lakhs green plants. And so this was done like that, and this was interior. See, this looks beautiful from the interior, and a large number of people visited this pavilion. It was very famous in Shanghai. So this is what we did. You can polish it, you can paint it, whatever you want to do it from the inside. And this is the final. You can see the people having the queue to go inside, and then enjoying it. They had to wait for some time because we have a small place inside. So they were waiting for even hours. And this is from inside. You will see that even bamboo was used in railing and all those things. And you can see here railing, in here also railing, but this is non-structural, this is easier, and this all was being done. And finally, this is the picture final where you can see. So basically what I'm saying is that bamboo can be used as a structural member, and this maybe in the future, particularly this bamboo is coming, and that treated bamboo, that this will be coming to replace as a construction material. I'm not saying that RCC will go away or steel will go away, but bamboo may also be one of the construction material of the future. So that is one. Two, again I am saying that treated bamboo is to be used, and this has service life more than 50 years. So durability is not the problem, and another advantage is there that corrosion is not the problem, and there's a lot of availability, and the cycle of maturity of bamboo is quite fast. That is, those are the advantages. And we should not hammer it, we should not nail it, and so there is a special arrangement which is to be used with bamboo. Problem is that when we don't do it, we don't treat it, and we use nailing or we use screwing, then we will not be able to get the desired result. So we are to come out with the specifications, proper specifications, how to be used in construction or as a structural members. Thank you very much. This is what I wanted to say in brief period. Thanks a lot. Over to you, Chairman.
Thank you, sir, for your presentation. We have been using this bamboo traditionally for so many years, but you have taught us how to use it scientifically, and I think with some efforts we can use it in mainstream construction. And now all the 6 presentations has been over, and I request if there is some question, so that we can get our speakers to answer them.
चैट में लिखा है क्या? चैट में देखिए, चैट में चेक करिए.
One question is in chat box, and I request yes, aluminum secretary. Question is for our speaker, Sri Rajiv Goel, sir. Is he present in, or he has left? Rajiv Goel, sir. He is present. Question is
उनको पिन करो.
aluminum factory, how to adjust different thickness of floor slab if required?
Rajiv Goel, sir.
म्यूट है अभी, तो एक तो अनम्यूट करना पड़ेगा उनको, या तो फोन कर लें उनको।
फोन कर देखना जरा, फोन छोड़ दो।
Any other question in the meantime? If anyone has another question with another speaker, you can take up that.
Hello. I wanted to ask Pathak Saab and if Mr. Salim can also respond. To what extent we are just talking about Griha rating to people who are like that is the level of the highest level of Maslow's laws. We are not having the physiological needs satisfied, and we are talking about the last stage spirituality to people, common people who are not even having the basic needs. So what should be done in that aspect so that we are able to satisfy them?
May I One minute. May I answer this question, by the way?
I'm also ready, sir.
By the way, somebody is asking about physiological needs and the self-actualization needs and other needs like social needs and safety needs. Everybody cannot satisfy all the needs. Some people will be able to satisfy their physical needs, and some will be able to satisfy physiological and safety needs, and some maybe physiological safety and then social needs, and maybe very few goes to self-actualization needs. So it's not that one, if one is not able to satisfy or say few are not able to satisfy physiologically, it doesn't mean that it will not go to self-actualization. Maybe that you are at third level or fourth level of needs and somebody is on this first level. So it is the society. It goes like that.
Sir, I was just asking relating to Griha. Not nothing to do with psychological thing. I wanted to talk regarding the Griha rating, what we are trying to sell to people. In that respect, I was just mentioning that.
Probably there also it will apply whatever he says. Right. There will be different stages and different classes of structures and people to whom it will apply. Same thing. Achha, Dr. Rajiv Goel is here, I think.
Yes, sir.
There is a question in the chat box. In aluminum shuttering, how to adjust different thickness of floor if required? Open the chat box, sir. The question is from Ram Dayal, sir.
Slab thickness is always adjusted by initial planning. In this, we reduce the means shuttering level downward. Means if you see the clearance of the room to room clearance, there is a variation. If it is a bigger span room, for example, it is a 5 meter by 6 meter, another is a 3 meter by 3 meter. In one we require 120 mm slab, in another 160 mm slab. We keep the top of the slab as same, but there is a offset in the shuttering in the bigger room. So the clear height of the room get reduced by 30-40 mm.
Hello?
Is that answered? Hello?
No, I was interested how to adjust the floor height. In case of the toilet, we usually keep it little depressed, whereas the room, the slab level is little higher. How to adjust that?
In this, if we want a 25-30 mm slab level difference to fill it in the later on, like in toilets, this is given in a steel frame was given fixed along with the shuttering to change the level of the top level of the slab.
Yeah, I was interested in looking for that change in the top level of the slab.
Yes, that is also possible. That is also being done.
How?
There is a frame which is fixed along with the shuttering, which created two different levels. The top of the frame give the level of the other side, and bottom of the frame give the level of the concrete to the other side.
Okay. Thank you.
One question from paramilitary forces. In monolithic construction, there is a prehension of more warmth and humid inside the rooms in comparison to conventional construction, particularly in Delhi and other cities. Any remedy or solution? This is question from
We have measured in Delhi, we have measured temperature variation in conventional building as well as in this RCC